solid design pattern is really important to learn as a software developer. So whenever you're writing your code, you should always follow the solid design pattern and you should adhere to it. It will allow you to create a very robust code and a really scalable code as well. Hey, what's up guys, and welcome to Daily Code Buffer. So I have just laid down the few examples here. So I will show you the examples, and with those examples we will understand what is going to be the good code and what is going to be the bad code. And accordingly, whenever you're going through the code, you can identify how you can improve the code readability, how you can improve on your code structure and everything based on the solid design principle, so you can improve your coding as well. So let's identify the code, and this will also help you to prepare well in your interviews as well. So we are going to create a complete series out of it where you will learn each and every design patterns and all the low level code as well. So as always, keep supporting. So let's first understand what are the different principles here. So in the solid principles we have 5 acronyms: SOLID. Let's start with the S. S stands for single responsibility principle, which means that whatever the classes that you create should only have a single responsibility. Now whatever the classes that you create, all those classes should have only one responsibility, and that responsibility only should be followed by that particular class. Now how to identify that this particular class has a single responsibility or not? You just need to ask the question like what this class does, and if you encounter and, that means that is not a solid design principle. It is breaking the rule, because you cannot have this and this both can be implemented by a single class. Okay, it should only do one thing and it should have only one responsibility. I have the example with a good code and a bad code as well, so let me just show you that. So if I open here in the solid principles, in the SRC I have kept all the code over here. Okay, so let's go with the single responsibility. So in the single responsibility, you can see that I have one account class available. Okay, this is the Pojo, where I'm just storing the account information, which has the account number, first name and the total amount in the available account and all the getter setters and everything. Now if I go to account operations class, okay, in this account operations class you can see that this class is created to do the operations on the account. Okay, what are the operations on the account? To add the account, to get the account details, and to update the account information. So that's the work of the account operation class. Okay, but here you can see that there is also a method called deposit. So the account operation class is only responsible for account related operations. The deposit operation, that you can tell that that's the transaction operations. Okay, depositing the amount or withdrawing the amount, that is the transactional details on that particular account. It is not the account operations. So here you can see that this is violating our principle that account operations class cannot do account operations and deposit or withdraw, or that is a transactional details, right? So this is breaking our single responsibility principle. So what we should do is we should create another class that handles the deposit. This account operation should only handle our account related operations. So for that reason, what I have done is, you can see, you can go to the transaction operations, and in this transaction operations you can see there is a 2 method. There is a deposit method and the withdraw method. So this way you should segregate the responsibilities. Your account operation should only be doing your account related work, and your transaction operation should only be doing the transaction related stuffs, that is the withdrawing the amount and the depositing the amount, and whatever the other operations that needs to be done as a transactions. Okay, so this way all the class should have only single responsibility, and whenever you encounter and, that's the violation of your principle. And if you go to the main class, you can see this way you should be calling it. You create the object of the account and you set all the details of the account, and with the account operation you add the account, and with the transaction operations you deposit the money or you can withdraw the money, whatever the transaction needs to be done. So both the things are separate. Now the next acronym is O. O stands for open close principle. That means any class or any interface that you create should not be open for the modification. Okay, it should be closed for the modification. Whatever the extra functionality that you need to add, they can extend the class and then you can add the any functionalities to it. Okay, so suppose you create a class and no one should be able to add any extra method to that class. Whatever the extra method or extra functionality needs to be added, a new class should be created for that particular functionality, should be extending that class, and then we can have the extension to the particular class. So we should be closed for the modification and extension should be allowed. So let's see the example with it. Let me just close all these methods here and let's go to the open close principle. First let's go over here. So here you can see that I have created a calculator class. This is a bad calculator. Okay, let's go by going through the bad code. So in this calculator what we are doing is we are just passing 2 numbers, and those 2 numbers, in that we are also passing one type, what we want to do. So here you can see that with a switch statement we are doing everything. That means if you are passing sum, then we are doing the sum. If you are passing sub, we are doing the subtraction, and that way. So here you can see that for each type whatever is passed, Okay, we are doing the switch cases. Now suppose if you want to add new operations like multiplication, division, then we need to come here and modify our code, right? So that means that's the violation of our open and close principle. We should not be allowed to modify our classes or objects that has been created. We should only allow to extend it. So this design violates that principle. So let's see how we can overcome this scenario as well. So if you come over here, what we have done is we have created one class that is operation. Okay, this is the interface that we have created, and this interface you can see will perform the operation. So this operation will be performed by the two numbers. Okay, now what we will do is this operation will be extended by the two class, that is the add operation, which will implement the operation and it will do the addition operations. It will just implement the perform operation that was mentioned in the operation interface. The same way it will do for the subtract operation as well. That subtract operation will implement the operation interface and it will implement the perform operation where we will do the subtraction. Now you can see that the operation interface that we created, and that interface is being used by the two classes, that is the subtract and the addition. Now if you go to the actual calculator class, you can see that now it's really simple. We just have a calculator and we are just doing the calculate number, and we are just passing two numbers, and then we are just passing the operations. Okay, we are not doing any switch statement or anything. The operation is passed and the operation dot perform method is been called. Now whenever we will be passing the add operation, addition will happen. Whenever we are passing subtraction, subtraction will happen. And if we want to introduce the new functionalities like multiplication and division, we can just extend the operation class that we have created, implement the perform method, and in that perform method we can write our logic that it's going to be multiplication or it's going to be division. And whenever from the calling method, that is the calculate number, at that time we will pass the division operation or the multiplication operation, and that code will be executed based on the perform method. So you can see that we are not allowing to modify the existing method or existing class. We are just allowing to extend the functionalities. So that's how we should be thinking in our mind, that how this principle should act in our projects as well. So this way we should think about, okay, whatever the class or interface that I have created, is it designed in such a way that whenever the new functionality is coming, I am modifying this particular implementation or not, or I am allowing to extend this and a new functionalities can be created based on the business logic. So that way you should keep in mind and design our code. The next acronym is L, that stands for Liskov substitution principle. Now Liskov substitution principle states that whenever you are creating a parent-child relationship, that is the parent class and the subtype class, so both the class should be interchangeable and should be substitutable. So that means whenever I pass the object of a child and whenever I pass the object of a parent, both should work. The code should be able to handle those scenarios. So we should be able to substitute our classes whenever we are passing the objects of it. So let's see an example what it means. So if I go to the Liskov here, let's understand the bad design first. Now you can see that I have a loan payment Java class. Okay, this is the interface created. Now this loan payment, you can see that there are multiple methods available. That is the do payment, force close loan, and the do repayment. Okay, these three methods are created. So these three methods needs to be implemented whenever I am creating a new class out of it. Okay, so this loan payment can be implemented by the home loan and the credit card loan. So both are the different types of loan and both of them can implement this loan payment. Okay, so let's see first example of a home loan. So in the home loan, you can see that home loan is implementing the loan payment, where it is implementing the do payment, force close loan, and the do repayment. All the three methods are implemented here. There is no issue. Now if you go to the credit card loan can implement the do payment and the do repayment, but it does not allow the functionality to force close a loan. Okay, so that's why you can see that it is throwing the unsupported operation exception. Now if you go to the loan closure service, now in this loan closure service, you can see that we have added the loan payment, that is the loan payment interface that we have created, and it has the force close loan. Okay, so which in turn calls the force close loan method of a class that we have provided. Okay, so whenever I am passing the home loan over here, okay, at this particular point, so from that home loan I would be able to close a loan. Okay, because I have a method available to force close a loan. Okay, but if I pass a credit card loan, so whenever I'm passing credit card loan, it will throw the unsupported operation exception. So that means you can see that whenever I am passing the child classes one or the other, I'm not able to fully pass it. One of the operation is not performing, right? So that should not happen. Okay, we should make sure that whatever the classes or whatever the implementation that we provide, all those should be substitutable. Okay, so let's see how a proper code we can do for this scenario. So if you go to the good code here, what I have done is I have created a loan payment interface which will just do the payment. Like whenever we are doing loan payment, it should do the payment. So from this loan payment, I created the another class, that is the secure loan. Okay, secure loan means we need to take the money back. So in that you can see that I am doing the force close loan. So you can see that I have made sure that whatever the methods are available, those methods are only I'm keeping in the interface. So loan payment is doing do payment and secure loan is doing the force close loan. Now if I go to the home loan, this home loan is implementing secure loan. Okay, now whenever the home loan is implementing secure loan, that means I can do the payment as well and I can force close the loan as well, because secure loan is having the method that is called force close loan. Okay, if you go here, secure loan, this is only having the method that is the force close loan. Loan payment doesn't have that. So home loan has the capability to secure the loan, but credit card loan does not have the capability. It will just implement the loan payment, like we can just do the payment out of it. So now if you go here loan closure service, you can see that it is just taking the secure loan. Okay, so whenever I'm passing this secure loan, it will have the force close loan method and this will be executed. So you can see that whatever the implementing class of the secure loan would be, that we are going to pass, or we can pass the secure loan and everything should work properly now. This way you can see that we just change our code so that it will behave properly whenever we are substituting the classes. Okay, earlier you can see that earlier in the bad code, whenever we were substituting the classes, it was throwing the exception in one of the methods. Now but here we just change the behavior itself, like the loan payment can be only do the do payment, but secure loan will do the force close loan. Okay, it will take the payment back as well. So whoever requires that functionality can go ahead with implementing the secure loan, and that way the code will work. So this way we should think about whenever we are implementing this principle. Now the next acronym is I, that stands for interface segregation. Okay, so we should create the interface in such a way that those interfaces should have a proper methods that needs to be implemented. I should not create an interface which have hundreds of methods, but a client does not require all those methods to be implemented. We should not force the client to implement all the methods which are not necessary to them. We should segregate our interface in such a way that whatever the interface has been implemented by the client, all those methods should be relevant to that interface. Okay, so we will see in the example how we can achieve that, but we should allow the client to implement those methods such a way that it's not a bottleneck for them as well to implement all the methods. So let's see with the design here with the code. Let's understand the bad code first. Okay, here you can see that I have created the DAO interface here, and this DAO interface, what we are doing in this DAO interface is, DAO interface we have created such a way that it can access the file system as well, and it can access the DB system as well, and with both of them it can do the operation. Either it can open the file as well, and it can open the database connection as well, and after that it can create a record or delete a record. So all this particular method declaration that we have done, that it can open a connection in DB, it can open a file as well, it can delete a record, and it can create a record. Now if I go to the DAO connection, okay, this DAO connection is implementing bad DAO interface for the database. Okay, so in the database I can open the connection, I can create a record, I can delete the record as well, but I cannot open a file because it's a database connection. I'm not worried about opening a file. So whenever I'm opening a file, we should not allow to open a file. So that's why you can see that we are throwing the unsupported operation exception. Okay, so that's the violation of the principle, that we are forcing the client to implement a method which they don't require. So here open file they don't require, right? They have to work with the database. So open file should not be here. If I go ahead with the file DAO connection, you can see that I can do open file, delete record, create record from the file, but I cannot open the connection because that is not what we are doing. We are not connecting with the database, we are connecting with just the file. So that's why this method is not relevant here in this particular implementation. So let's see how we can improve one. So if we go to the here in the good package, what we did is we segregated the interfaces. We created one interface, that is the DAO interface, and this DAO interface just have two methods, that from this DAO interface either you can create a record or you can delete a record. Okay, And on top of that, what we did, we created the DB interface. Okay, and this DB interface will allow you to open a connection to the database. Okay, that's only one method we have defined, and we have created the file interface which will allow you to open the file. Now you can see that all the interface have the different methods and appropriate methods as well. Okay, now whenever we want to implement the file system, right? So if I go to the file system, file DAO connection, what I'm doing is I want the DAO interface. That means I want the create record and update record functionality, or delete record functionality, plus I want to interact with the file. So that's why I'm implementing two interface, that is the file interface that will give me open file functionality, and I am implementing DAO interface which will give me delete record and create record functionality. Okay, similarly if I go to the DB DAO connection, I am implementing the DAO interface which will give me the functionality of delete record and create record, and I am implementing DB interface which will give me functionality to open a connection to the database. So you can see that how neat it is. Like from the implementation part itself, we will get the understanding, okay, what is this interface doing, what is this interface doing. Both have their own responsibilities, and whatever client needs, client can implement those interface. Those implementation can be added by the client according to their requirement. Now we are not forcing the client to implement or add the implementation of any classes or methods. Now the next acronym in the solid design pattern is the I. I stands for dependency inversion. So which means that we should not be having the any dependency on any modules or any sub modules. So higher level modules should not have the dependency on the lower level modules or the classes or objects of it. Okay, we should design in such a way that it should not have the dependencies on each other on the different classes and objects. So let's see with the example so we'll get more understanding. So if we go here in the bad design, we will take the example of the same calculator that we did in the open close principle. So here you can see we have the calculator, and in this calculator you can see that we have the calculate method, and in this calculate method we have a shift switch operation where we are passing the operation. So whenever we are passing the add, I am creating the object of a add operation, and whenever I am passing sub, I am creating the object of the sub operation. Okay, simple thing. And I have the add operation and I have the sub operation. Now you can see that with this design there is a flaw, because you can see that what we discussed was your higher level module should not have the dependency on your lower level modules. Okay, so your higher level module is your calculator. Okay, that's the calculate method, and this calculate method has the dependency on the add operation and the sub operation, because you are creating the objects of those here itself. You need the object of the add operation to be created to use that in your calculate method. So that means you are not doing the dependency inversion. You have the dependency that you need or you are creating by your own. So what we have to do is we have to change in such a way that we are not directly dependent on the classes or objects that have been created. Okay, so for that let's understand the better way. So what we are doing is we created the add operation here, right? So this add operation is implementing calculate operation. So we just created one calculator operation here. Okay, this is the interface, and what calculator operation will do is calculator operation will have one method that is calculate. Okay, it will take two numbers and it will do the calculation based on the implementation that we provide. So this calculator operation is been implemented by the add operation. You can see this is implemented by the add operation, and this calculate method is doing a plus b. It is also implemented by the subtraction operation. Okay, subtraction operation implements calculator operation, and it is doing the calculate method with integer a, integer b, that is a minus b. Now if we come to the calculator, you can see that we have no dependency. What we are doing is in the calculate method we are just passing the two variables, that is the int a and b, and then we are just passing the operation. Okay, we are not creating any objects or anything. Whatever the calculate operation that you pass here, either you pass add operation or sub operation, that will be calculated directly. So now in the future when you add multiplication operation or the division operation, you just go ahead and implement the calculator operation interface. You give your implementation, and whenever you're calling the calculate method, you can just pass that division operation and it should work. So you can see that there is no dependency available. Everything will be handled easily here. So you do not have to go ahead and create different objects based on some other conditions. Everything will be handled with the interface itself, and that interface you have to implement based on your requirement. So now you can see these are all the things that we learned about the solid design principles. This will be very helpful in your interviews as well, because in the interviews this is the standard question that you will be asked, as a software engineer role, that what is solid design principle and how you should be implementing your code. And whenever you are going in your LLD design level rounds, at the time also this type of things will be taken in picture whenever you are being evaluated as well. So make sure that you understand these concepts very well, because concepts is important, and whenever you are implementing your code, make sure that you recall these concepts and accordingly you design your code. I would always suggest that don't directly jump into the code. First design it, like what methods you will be requiring, what particular interface, objects and all things you would require. Design it on paper or draw.io or anything. Just get the visual understanding, and then it will be very easier for you to implement your code as well. In this video, we are going to learn about the Singleton design pattern. So let's get started. Now, before we understand the Singleton design pattern in Java, let's first understand what is Singleton object. So here, let me just show you within your application, whatever the objects that you create, we can create the objects in the different ways. So within your application, you need your objects to be created only one time. At the time, we will create the Singleton object. So suppose if you take the example here, okay, this is the object, and here you can see I am just telling that this is a DB connection object. So whenever from my application, whenever I want to do any DB operations, what I will do is I will refer to this object that is already created, and I will use that particular object to do all my queries. So that's the idea about the Singleton object, that you will create the object only once, and the same object you will use across your application. So you won't be allowing to create another object with the same specifications. Okay, so here within this DB object, what you will have is you will have all the DB properties like URL, password, everything, where it's going to connect, how many connections and everything that you have. And the same connection and the same object you will refer every time to create the queries or to have the DB connections and everything. Okay. Now, to create the object as a singleton, we have to follow few properties. What singleton object means, that whenever you are creating the object from the class, right, we will be defining the classes, right? So this is a class. So whenever we are defining the object of that class, we should only be having only one object. Okay. So this is a DB connection class. So whenever I take the object, or whenever I want to use the object of this class, I should only be having one class. Now, how we will do the code in such a way that it will result in only one object. So for that, when we define the class, right, the name of the class, suppose it's an app. How generally we create the object? We create the object using the constructor. Okay, so whenever a constructor is called, it will create the new object. So what we will do is we won't allow objects to be created using the constructor. Okay, that's a simple thing. So what we will do is we will give a private constructor. So if we give the private constructor, no one would be able to create the object of it. Okay, that's the first thing. Now, but we should be able to create the object once. So for that reason, what we have to do is we have to have one static instance of that particular class, and with one static method, we should be allowing to create the object. So for this class, whatever it is, we can have a static field, and with this static field, we have a static method, and with this static method, it will return this object. Okay, that's the only one thing. So whenever we will call this static method from this class, it will return the same object every time. We won't be creating the new object. That's it. And whatever the properties we have, right, within this class, whatever the properties that we define in this class, those also should be static and be directly instantiated. Okay, that's it. So once we define all these properties, that particular class will be always singleton, and no new object will be created when we are working with that particular class. So this was all about the theoretical part, like what is singleton class and what are the properties that we have to define to create a singleton class. Now let's see in action, like how many different ways that we can create the singleton class and how we can break it as well. So let me go to the example here. I have few examples noted down here. You can see that I have few examples here. Now let's start with the basic example. Okay, here you can see this is a very basic example where I have defined that this is a lazy singleton class. Now you can see that this class I have created, and for this particular class I have created a private constructor. So that means no one will be able to create the object of this class. Okay, so one thing that we have followed from the principle. The next thing is we should be having the static instance of this class itself. So here you can see that we have defined private static lazy singleton as the instance equal to null. So we have just defined the same class as the instance here, and with that we have defined one static method that will instantiate the object and it will return the same object. So here you can see we have defined that if instance equal to null, then create the instance of the lazy singleton and return that particular object. So if the object is already created, then it will return the same object every time. So now whenever I'm going to call lazy singleton dot get instance method, it is going to return me the same object that is defined here. Okay, so it will always result in the same object. Cool, right? This is how you will be creating the singleton classes, which will result in only one object when you're working with it. But now when we are working with the multi-threaded application, when we are working with the multiple threads, we need to take care about those multiple threads as well. So within this example only, let's see, like at this particular point within this method, if two threads are trying to use the same method, same object, that is the lazy singleton.get instance. So both the threads will come here at this particular point, and from that both the threads, it will go to this particular line of code, that is the instance equals to new lazy singleton. Then for both of those threads, the new object will be created and that new object will be assigned to it. So you can see that with this singleton class, multi-threaded approach is not handled here, right? Because both the two threads is getting the new object of the singleton class. That is violating the principle of the singleton design pattern. So how we can handle this? The first thing that comes to our mind is to make this lazy initialization to the eager initialization. So if we take this example of the eager initialization, what we are doing is, when we are declaring the object, at that time only we are instantiating that particular object. So when the class is loaded in the JVM itself, at that time only the object will be created, and JVM will ensure that whenever any thread is trying to access that object will be created first. So from the get instance method, you can see that we have directly returned the instance here. We have not added any null check as well. So within the JVM, that class will be loaded and the object of that particular class will also be created at the initialization steps only. And whenever any thread is trying to access it, it will only get one instance. So we solve the multi-threading problem here, but the issue will be like, if we are not using that particular object, then also that particular object is created and stored in the memory. So it will utilize the resources, and those resources, if not used, will be wasted. So what it will do is, it will create the object though we are not using it. Okay, if you're using it, that's fine. But if you're not using it in our application, then also this object will be created. It will be there in the JVM and it will be useless. So you can see that it is solving one problem but creating another problem as well. So how we can solve this problem, where we can have the singleton class as a thread safe as well, and we are not using enough memory as well. So for that, let's go to the multi-threaded singleton class, like how we can have the multi-threaded singleton. Okay, the first thing that you can do is, whatever the method get instance is there, that method you can make it as a synchronized method. Once you make the synchronized method, what will happen is, only one thread at a time can access that particular method. Only one thread will be able to call that method at a time. So at that time, what will happen is, if multiple threads are trying to call this method, one method will be executing that particular method and the object will be created. So till that time, other two threads will be waiting for first thread to be completed, and then only another thread will come, and after that third thread will come. So here you can see that there is a long waiting time for multiple threads. So if you have hundreds of threads, then all those threads will have to wait until all the threads complete their process. So for that, rather than using the synchronized methods, what we can do is, we can use the synchronized blocks. So within the synchronized blocks, what we will do is, we will only add the synchronized block where we are actually creating the object. Because whenever we are creating the object, that point only we have to make sure that we have a synchronized process, because at that time only we want to make sure that only one thread is creating the object and the other thread is just using that object. So rather than making the entire method as synchronized, we will just make sure that couple of lines only is synchronized. Rest of the things can be directly be utilized by the other threads. So for that reason, what we are doing is, within the multi-threaded singleton class, we had one private constructor. That's a default thing that we have to do. Then we have the instance of the multi-threaded singleton class as well, where we have defined as a null, because we are not going with the eager initialization. Okay, because eager initialization will waste the resources. So within this multi-threaded singleton, what we are doing is, you can see we are first doing the null check. Okay, that if the instance is null, and at that time only we have to create the object, and that particular portion only I have to make sure that that's the synchronized block. Okay, if the object is already available, then I can directly return the object. That's a simple thing, right? So now if the object is not available, okay, if object is not created, it's null. So at that time, that block I have to make sure that's synchronized block. And as this is a static method, we are using the class level object locking itself. Okay, so that's why we have defined multi-threading singleton.class as the object lock. And within this, you can see I have again done the null check, and then I am creating the instance here. Now why I have done again null check here, because you can see that synchronization starts from this point only, but here is the point where we are doing the null check. So still here multiple threads can come to this point, and if the object is not created, all those threads can see that the instance is null and they can still come to this particular point. So till this particular point, if object is null, all those threads will come here and they will know that okay, object is null. So after that, within the synchronize block, we have done that if instance equals to null, then create the instance. Okay, so first thread will come here and it will check, okay, the instance is null, so create the instance. Then second thread will come here and it will check, okay, if instance is null, no, we already created it, right? So at the time it will skip this and it will return this instance from here. Okay, so you can see that we created a synchronized block, and from that only one thread will go here and it will create the instance, and rest of the threads will come here. It will check for the instance is equal to null. If not, it will directly return the instance. So from here we can understand that our Singleton class is thread safe as well, and it will not utilize that much resources as well. So it is going to be pretty efficient Singleton class. Now though you can see that we created a pretty efficient Singleton class, but can you break the Singleton pattern? That is the question every interviewer will ask you, how to break the Singleton design pattern and how we can solve that problem as well. Let's understand that as well, because that's a really important thing to know about the Singleton design pattern as well. So till here we understood how to create the Singleton design pattern in different ways. Now let's see how it will work. Okay, so what I will do is I will go to my main class. Okay, and here I have created one main method. Okay, that's a simple main method, and I have created the example serialization. So serialization is one of the ways that Singleton pattern will break. Okay, what serialization will do is serialization will convert your object into the byte form, and that particular byte form data can be sent over the network or for the different files and anything, and file retrieving back that byte format data will be again changed to the object. Okay, so that's a similar thing that we are going to do here. We are going to convert our object into the file, and when we are retrieving, we will retrieve from the file and convert to the object. Okay, that's a simple thing that we are going to do. So here you can see that in the example serialization method, I have used the lazy singleton class here. Okay, and you can see with lazy singleton class, with lazy singleton.get instance, I am getting the instance. So I got the instance here. Okay, and this is going to be the singleton instance. Now what I'm doing is using the object output stream, I'm converting this lazy singleton and I'm writing to the output stream here. So whatever the object was there, I am storing that object in the object.obj and writing this class into that. Okay, so my class would be saved in the object.object. Now with the object input stream, I am reading this object.object. So whatever the data is there in the object.object, I am getting in the object input stream, and with the read object, I am converting back to the lazy singleton. Okay, so that's the normal thing that I'm doing here. Okay, nothing fancy. I'm storing into object.obj and reading from the object.obj file. Okay, and I'm closing the object. Now, how we will get to know that two classes are same? Those will be based on the hash code values. So here what we are going to do is we are going to check the hash code of the two objects that we have, like the first object that we created and the deserialized object that we have. Okay, if both the objects have the same hash code, that means both the objects are same, and that's the singleton class. Okay, so let's run this and see what happens. And here you can see that we got the object 1 and object 2, and both the values are different. That is the object 1 hash code and object 2 hash code. Both the values are different. That means both the objects are not same. Okay, we should be having the same hash code to make sure that it's the same object. Okay, so this is violating our principle of singleton, that only one object should be created. So how to solve this? This is a pretty big issue, and this is very common as well, like we do the serialization of objects in our application. That's a very normal process to do. So to handle this, what we have is we have one read resolve method. So if we go to the serializable singleton here, okay, here you can see that it is the same code as the lazy singleton object, but we have one method that we have overridden, that is the read resolve. Okay, now what read resolve method will do is, read resolve method will be called when you are doing the deserialization of the object. JVM itself will call this method. We do not have to call it when the deserialization happens for the particular object. This method will be called, and whatever the process that we have to do, we can do within this process. So what we are doing is we call this method read resolve, and what we did, we return the same instance available. So rather than deserialization method getting the byte array and converting back to the object, what we did is in the read result method, just use the same object itself. You don't have to deserialize and do all the processes, just use the same object. So you can see that whatever the object that we have defined, we are just returning the same thing here. Okay, so now whenever the deserialization happens, we should get the same object back. Okay, so let's use this serializable singleton and check our code. So we will go back to main. Okay, and what I will do is I will uncomment this, and here you can see that it's the same thing that we have done, right? Rather than the lazy singleton class, I am using the serializable singleton, and the same thing that I have done, I have created the instance and I am storing in the object1.obj. Earlier I was storing in the object.obj, and the same thing read I am doing. I'm reading from the object input stream from the same object1.obj file, and I am printing the hash code values of both the objects. Okay, that's a simple thing that I'm doing. So now if you run this for this particular lazy singleton, we should get the different hash code, but for the serializable singleton, we should get the equal hash code. So let's run this and let's see what happens. So here you can see that for the object1, object2, we got the different hash code, but for the serializable singleton, we are getting the same hash code value. You can see that the hash code values are same. So here you can see that serializable was one of the ways that can break the singleton, and we fix that as well with the serializable one. The other way to break the singleton design pattern is using the reflections. We already know that using the reflections, we can call all the different methods, constructors, and everything within the class. So let's see how we can break the singleton design pattern using the reflection and what is the way to solve that as well. So here you can see that within this example reflection, okay, let me just comment this and enable here. So within this example, you can see that we have one method that is the example reflection, and what we are doing is within the lazy singleton.class, we are getting all the declared constructors. Okay, and what we have is we have one constructor declared within the lazy singleton, and that is also private. Okay, as we have declared private, no one would be able to create the object of the singleton. Okay, that's why we made it a private one. So what it is doing is using the reflection, it is trying to get all the constructors of the class. Okay, we got all the constructors, and it is taking the first constructor because we only have one constructor. It is taking the constructor and it is changing from private to public. You can see it is changing the accessibility. So if when we make it true, it will change from private to public. Okay, so now your constructor is visible. So with the constructor.getNewInstance, it will create the new object, and that new object will be stored in this singleton. And within the lazy singleton instance, using lazy singleton.getInstance, which is going to give the new instance created. So that is also going to be the new instance that is going to be created. So you can see that we broke the singleton design pattern using the reflection here. We changed the private constructor to public, and with that constructor we created one object, and we created one object using the getInstance method that we have. Now if you run this, we should be getting the value. You can see that reflected hash code singleton is different, and the singleton instance, this is also different. So both the hash code values are different. Now to solve this issue as well, like breaking off the singleton design pattern using the reflection, we can use the enums. So if we go here, let me just open the enum singleton. You can see that what we did, we just created the enum singleton and created the instance of it. Okay, now this will solve all our problems, because whenever we declare the enums, by default those are static values, so we can directly call them, and whatever the constructors are called, users or we as a developers cannot call those constructors. JVM itself will call those constructor and create the object of it, and it will send us. And as enums are thread safe as well, we don't have to worry about the thread safety as well. So when we are creating the singleton objects using the enums, that is going to be the thread safe as well, and it is not going to break using the reflections as well. So here you can see that we did nothing. We created the singleton object, we defined the instance as an enum here, and we have some methods. So whenever we want to call any methods within the singleton, because that's what we do, right? So we can call using the enum singleton.instance.do something. Okay, so here you can see that I have defined the same thing here. Like whenever I want to use this, we can call it this way. So this will always result in the singleton object, and we will be able to call each and everything this way. So it will always result in the singleton design pattern. So these are the different ways we can create the singleton object, and we also saw the different ways to break it and how to fix it as well. So if you know this, you will be able to answer this question in your interview very well. So whenever you are going for the interview, this is the question that you will be asked a lot, and all these different permutations and combinations will be asked for your singleton design pattern, like how many different ways you can create, how you can break it, how you can fix it and everything. So we covered all those topics here. So if you have any doubts regarding any of the things that we have covered, then you can always ask me in the comment sections below. In this video, we are going to learn about the factory design pattern. So first, let's understand what is factory design pattern. So let's take the example of Tata Motors here, and we know that Tata Motors is creating the EVs as well and the normal diesel and petrol car as well. So let's take that example to understand it better. So we have the Tata Motors available here, and Tata Motors is creating EVs as well and traditional cars as well. That is going to be the petrol and diesel. So Tata Motors is creating two types of vehicles in their factories. Now suppose they launched a new model, and with that model they want to launch in the both variants. They want to launch in the petrol diesel variant as well, and they want to launch in the EVs as well. So let's take the example of the most popular EV, that is the Tata Nexon here. So Nexon comes in both the variants. It comes in the EV as well, and it comes in the petrol variant as well. So now they decided that they are going to create this Nexon in their factory. Now within the factory, they are going to create the Nexon. But for creating the EVs and creating the petrol car, they will need the different spare parts, and the process also should be different, like how you create the different cars. So here let's take the example that within the EV, what you will need is you will need the motors and you will need the battery pack as well. But within the traditional car, what you will need is either you will need a petrol engine or a diesel engine. So I'll just mention that either we will be needing the engines. And then what we will need is we can need the seats, right? But the seats can be same in both the variants. Then we need is wheels. So wheels can also be the same in both the variants. We need the infotainment system as well. And here as well we need the infotainment system. So infotainment system can also be the same, but you can see that the deciding factor about the two different types of car is just the how you build the engine part or the battery pack or the motor part, right? Because in the EV you don't need the engine, you need the motors and the battery pack. But in the petrol or the diesel car, you need the appropriate engine, either it would be petrol or diesel. Okay, so whenever I want to make a car here, so if I want to make a car, what I can do, what I can tell that, okay, let's make a car. Okay, and here I can pass, okay, let's either make a EV or either make a traditional car, where I will pass the information, okay, I want to make a car, but it's a EV, so I can pass, okay, make the car with motors or battery pack. Okay, here I can say make the car with engine. Okay, rest of the things you can see that those are the default things that I want to add. Okay, I want to add the same seats, I want to add the wheels, I want to add the same infotainment system, and rest of the things are everything the same. Okay, the only deciding factor changes here either motors or the engines. So internally how it is going to create the EV or how it's going to create the traditional engine car, I don't care. I just need the product out. Okay, so within the factory from the assembly process they can define, okay, is this going to be the EV? Okay, so they can define the EV parameters. Okay, rather than engine, put the battery pack and the motor, rest everything is same, so rest everything can be in the same assembly line. For the traditional petrol, rather than the battery pack and motors, keep the engine, rest of the things should be the same. Okay, so with this we can design our creation in such a way that based on some parameters we can create the objects of it. Okay, so based on the parameters, like either it's going to be the EV or it's going to be the traditional petrol engine car, with this we can create the object or we can create the final product that is going to be the Nexon car. So you can see that the creation part, how that particular car is going to be created, that I don't care. Okay, that's fine. That's the assembly line that we can create, okay, that they can create. But the idea is based on some parameters, it can internally decide like how we are going to create it. So within the factory design pattern as well, we are going to decide based on some parameters like what type of objects that we are going to create. Okay, here if I get the EV as the input, I can create the EV, rest of the things I can keep it the same. For the petrol engine as well, if I get the petrol engine as the input or petrol car as the input, I can create the Nexon petrol car. So this is how the factory design pattern will work. Let's take one more example. Suppose you're creating one application and that application can run on Windows as well, right? And on the Linux as well. Okay, it can run on both the applications, but we know that the file system in Windows and file system in Linux is completely different. So whatever the commands that you want to execute, those commands is also going to be different, right? How you handle the files in Windows and how you handle the files in Linux, those are also going to be different. Now I need to make sure that whenever I am executing those commands, I can execute the commands based on the operating system that is been defined. Okay, so if I tell the system that okay, I'm going to run these commands but on the Windows, so if I pass Windows, okay, I will get the Windows object, and all the commands which are there, those will be executed directly on the Windows itself, because those commands will have the implementation for the Windows. Same way with the Linux, if I pass the Linux, okay, we will have the Linux object created and all the commands defined for that will be executed. So you can see that based on some parameters, we are creating the objects of it. Okay, and based on that objects, everything should work accordingly. So that's how the factory design pattern behaves. So let's take this same example and let's understand more. So here you can see that I have the example here, okay, and I have the example of the operating system, and I have multiple operating systems. So here you can see that I have created the abstract class, and this entire principle works on either abstract class or interface. You have to create the interface of the abstract pattern and the implementation for it, then only we can create the factory design pattern. Okay, so here I have created the operating system class, that is going to be the abstract, and all the information which are basic that we have assigned here. Okay, so this is going to be have the version, architecture, we can set the version, we can set the architecture type, and you can see that the only two methods that we have defined as the abstract methods, that is the change directory and the remove directory, because these two methods will be different based on the different operating system. So the same thing for the Linux operating system. If you go to the Linux operating system, we have defined that is going to be extending operating system, and here we created the Linux operating system object based on the version and architecture that we pass. Okay, so whenever I want to create the Linux operating system, I have to pass which version and which architecture. Okay, and accordingly it will create the object for me, and I have implemented these two methods as well, that is change directory and remove directory. So the command for Linux would be different. Similarly, if I go to the Windows operating system, I have done the same thing. Windows operating system will also extend operating system, and within the constructor we can create the object, but change directory and remove directory will have its own implementation where we can pass the Windows command. So this way you can see we define the operating system and we define Linux operating system and Windows operating system. Both will be extending the operating system abstract class. Now how we will be creating the objects? Okay, so let's see here. So if we go here, we have created the factory, and that factory is operating system factory. Now you can see that once we created this operating system factory, we have make sure that the constructor is private. You won't be able to create the factory directly. You have to call the get instance method that is going to return the operating system. Okay, ideally you don't need the object of the factory, you need the products of it. I need the operating system, okay, rather than the operating system factory. So whenever I'm calling this operating system factory.get instance, in that I will pass what type of operating system I need. Either I need Linux or Windows, that I will pass, and I will pass which version I need, and I will pass which architecture I need. With this three information, okay, with the type itself, it will try to identify, okay, either I have to create the Windows operating system based on the Windows, or I have to create the Linux operating system. Okay, so you can see this, all of the objects are created based on the parameters that we got, based on some logic or some condition. So accordingly the objects are created, and we got the object from the factory itself. You can see this is the factory, and from that factory we got this object. So now you can see we are not directly creating the Windows operating system object or the Linux operating system object. We are just calling the get instance, and in that get instance I'm telling, okay, I need Windows or I need Linux, I need this version and this architecture, and get me the object. That's it. We don't have to worry about how internally they are creating the object. So this is how you can create the factory design pattern based on some conditions. Whenever you're creating the object, this is what you can follow. So these are the questions asked a lot in the interviews, so make sure that you know all this easy design pattern as well. So whenever you ask like what are the different design patterns that you know, make sure that you know all this so you can explain. So make sure that you at least know one from each categories itself. In this video, we are going to learn about the abstract factory design pattern. So let's get started. So in the earlier video, we saw about the factory design pattern. Here, abstract factory design pattern is the factory of the factory design pattern. So we'll be having the abstract factory, and within that there will be factories which will create the different classes for us, okay, or it will create different objects for us. So let's go through an example and let's understand more about the factory design pattern. So here I'm taking the example that I want to create the application, and this application can also be a Windows application, and it can also be the Mac application, and the application might contain the UI logic that it will contain some buttons, some list, some text, some drop down list. These are the different UI components that this application will be having. But when I want to create the Windows application, I want to use Windows button, and I want to use Windows list, I want to use Windows text, similarly Windows drop down, because that should be the proprietary for the Windows one. But when I'm creating the application for my Mac, I want to use the Mac button, I want to use the Mac list, Mac text, and Mac drop down list, which is proprietary to the Mac application. As we already know that both these operating systems are different, and based on that operating system there will be different UI components. So similarly, when I'm creating the application, I want to do the same thing. Like whenever I'm going with the Windows, all those components should be loaded and should be added as per the Windows application, as per the Windows operating system. And whenever I'm going with the Mac, all the components should be with the Mac operating system. Okay, so here I can say this is one of the factories that it will create the Windows application for me, and there is one more factory, that is the Mac UI application factory, which will create the Mac UI application for me. And this application is the another factory, that is the abstract factory on top of the Mac factory and the Windows factory, which will create the applications. Okay, so whenever I want to create the application, I can just tell that, okay, I want to create the application. Which application? I want to create the Mac application. Okay, so I'll just pass that I want to create Mac application. It will again in terms go to this Mac application, it will create the classes for it, and it will also create the similar classes for this UI components as well. Okay, so this Mac will not go to create the components based on the Windows, it will only create based on the Mac. Similarly, when I'm going ahead and telling this application that I want to create the Windows application, it will in terms again create the Windows application, and it will load this components only, it won't load this components. Okay, so you can see that I have the abstract factory, that is the application, and within that application I can define, okay, I want Mac or Windows, and accordingly all those components will be loaded by default. We do not have to tell anything, okay, when I'm going with the Windows, load this, and similarly, okay, everything will be loaded by default as per the factories that we have designed. So let's see this by example, how we can implement this. So let me go to my IntelliJ IDEA. Okay, and here you can see that I have created some of the classes which will depict the same thing that we have explained here. So here you can see that I have few of the classes. Okay, here you can see that I have UI factory. Okay, and this UI factory is the interface, and this UI factory may contain two methods, that is the create button and create checkbox button. Okay, two methods to add the button and checkbox, and this button and checkbox are again the interfaces. Okay, this is a standard button, and a button is painted, and we have a checkbox, and that checkbox is also interface, and which is going to be painted in the application. Okay, two simple things. Now this UI factory is implemented by the Windows UI factory. Okay, you can see that this Windows UI factory is a class that is implementing UI factory, and we have implemented two methods, that is the create button and the create checkbox button. And you can see this will return the Windows button we have created. You can see if you go to the OS, and within the Mac I have Mac button and Mac checkbox, and within the Windows I have Windows button and the Windows checkbox. You can see these two proprietary buttons are there, right? You can see Windows button is again implementing the button that's going to say this is a Windows button, and Windows checkbox is going to say this is a Windows checkbox. Similarly, Mac checkbox and the Mac button. Okay, so this you can see the components are different, and this component will be loaded based on the UI factory. So within the Windows UI factory, you can see we are passing return new Windows button and return new Windows checkbox. And within the Mac UI factory, we are passing within the same implemented method, that is the create button and the create checkbox. And within that we are passing return Mac button and return checkbox button. Okay, so ideally whenever I have the object of Mac UI factory, that will give me Mac button and Mac checkbox by default, right? Because we have the implementation that way. Similarly, when I have the object of WinUI factory, I will get the button of Windows and Windows checkbox only, because we have implemented that way. So that factory layer is that based on the individual factory, either it's Windows and Mac, I will get the supported UI components. Now if I go to the main application, that is the main factory itself. Okay, so this application, and within this application we have defined that this application will contain button and checkbox, because all our applications should contain button and checkbox. Okay, and we have created a constructor here. Okay, and this constructor is taking the UI factory. Okay, that's the another factory. Okay, that's the UI factory. Now within this factory, you can see that we are calling factory.create button and factory.create checkbox. Okay, and we are calling those methods. Simple thing. Okay, so you can see that this application, that's the factory of factory, that is just taking one input. Give me the factory and what I want to do. Okay, so here you can see we are just taking the factory, and from that factory, whatever the methods are available, those methods we are calling and setting those values. Simple thing. Okay, now how we will call this actually. Okay, so if you go to the main method, okay, and here you can see that we want the application to be created. Okay, in the main method we have defined that we want application to be created, and it's going to be the new application, and within this new application we have the constructor where we have passed the UI factory, and we want to pass the implementation of the UI factory, so we pass that win UI factory. Okay, so now all the components of the Windows UI will be created and that will be displayed here. Okay, so you can see we created an application, that's the factory of factory. Within that we pass that we want UI factory. Okay, which UI factory? Windows UI factory. So now whatever the application.paint we will do, everything will be based on the Windows. So if I run this, you can see that we got the Windows button and we got the Windows checkbox. Okay, we have not added any conditional checks or anything anywhere. Okay, based on the object that we are passing, everything is loaded up. Similarly, if I just pass Mac UI factory, okay, everything will be related to Mac now. Okay, you can see there, now we have the Mac button and Mac checkbox. How easy it is, right? So this way, whenever you have an abstraction layer based on the factory design pattern, we will be using the abstract factory. So you can see that this is very easy to implement and it is very easy to explain in your interview as well. So whenever interviewer asks like which are the design patterns, you can go ahead with all the simple design patterns first, so that you will have the basics clear. Then if interviewer asks, you can go with the difficult patterns as well. In this video, we are going to learn about the builder design pattern. So let's get started. Now, whenever you want to create the object step by step, all those complex objects you want to create step by step, at that time we are going to use the builder design pattern. Builder design pattern is a part of creational design pattern, so it will be used when you want to create the complex objects. So let's understand with one of the example here. So suppose you want to create the house. So this is a simple example that we are taking. Suppose we want to create the house. Now, whenever we want to create the house, what we need to create the houses? Okay, we need the walls, we need windows, we need rooms, we need kitchen, some stuffs. Okay, these are standard stuff that we need in a house. Okay, now suppose I want to create a house that has a swimming pool as well. So I want to have another house. So you can see that I want to have one house which has walls, which has windows, rooms, kitchen and swimming pool as well. And suppose someone tells me that I want a house which has more properties or more features as well. So suppose I want to have the house as well, which has all the things, that is walls, windows, rooms, kitchen. I don't want swimming pool, but I want 2 parkings, suppose, right? So you can see that these are the different features. You can see that someone is asking that I want this particular thing, I want this particular thing. So one thing we can do is, okay, we have the option, okay, to give, okay. Either what we can do is whenever we are creating the object, right, of a house. So suppose if I'm creating the house object, okay, I have some properties. So suppose let me create a class house here. I have walls, windows, rooms, kitchen. These are all the properties, right? And what I can do is I can have the constructors here. So I can have the house constructor, which is taking all these properties, walls, windows, rooms, kitchen and everything. Okay. Now someone comes and tells that, okay, I want swimming pool as well, but my constructor doesn't support it, right? My object creation doesn't support that. It should have the swimming pool as well. So what I can do is I can have one more constructor. I can give house, which is taking window, walls, rooms, kitchen and swimming pool as well. Okay, so now you can see that my class have the capability to add the swimming pool as well. Now someone comes and tell, okay, I want parking as well. So what I will do is, okay, I will add one constructor that will have the walls, windows, rooms, kitchens, swimming pool as well and parking as well. Okay, so you can see that we will end up with a lot of constructors here, right, to have the object creation based on the different representation of the same object. Okay, so you can see that this representation is different of object with this representation, and the same with this representation. Okay, all the objects are house object only, but the representation is different. What are part of that particular objects are different. So if you end up in this type of scenarios, at that time we will use the builder design pattern. Now how builder design pattern will help us? So builder design pattern will help us in such a way that whatever the objects or whatever the properties or features we want to add, we can assign those, and it will help us to create the object of it. Okay, so if I create the house object, okay, this is a class house, and what I will do, I have all these properties. Okay, we have walls, windows, rooms, kitchen, we have swimming pool, we have parking as well. Okay, everything we have as a different features or different properties here. And what we will do is we will also provide one builder class. This builder class will be the inner class of the house class itself, which will help to create the object. So rather than passing everything in a constructor itself, what we will do is we will use the builder class to create the object. Okay, so what we will do, we will use house builder. We will create one class that is house builder. Okay, and within this house builder, what we will do is we will pass all the things. Suppose if I want to add walls, so we will add house builder dot walls. We'll have one methods to add walls, and we can add walls. How many walls we need? Suppose 4 walls. Okay, we have whatever the properties we need, we can add. Okay, we can have one more method, that is the windows. So you can see that we have the option to add windows. Suppose 2 windows. One more method we can add to add the swimming pool. Okay, one swimming pool. We have the method to add the parking as well, so we'll add one parking. Okay, you can see that all these different methods are that. With those different methods we can assign things like what I want to have in the house. So you can see that this is just a part of the house builder, and whatever the features you want to add, everything you will be adding, and at the end we will have one method, that is a build method. And this build method, what it will do is whatever the values are assigned here, okay, whatever the features are assigned here, it will take everything and it will return the house object. So now we are not forcing client to add each and everything in the object creation. So we are not forcing that, okay, if you don't want swimming pool, but still you have to add the swimming pool, though it's not visible, you can say no. But okay, so we are not forcing that way. We are giving the option to the client, like whatever you want to add those things, and we will create the object for you. Okay, we will create the product for you. So we are giving control to the client itself. Okay, so that's why you can see that the step-by-step creation they can do with the different representation of the same object. Now suppose tomorrow they will come, okay, they will use this house builder and they will not add anything, and they will directly call the build object. Okay, but you need some basic properties, right? You need some walls, windows and everything to have the base house ready. So for that, what you can do is whenever there is a build method called, you can have those validations as well. Like these are the basic things that you need to add while creating the object of it. Okay, so those validations also you can add. So this way you will provide the base properties, like these properties should be needed to create the object, and you will give the option to add different properties based on their requirement itself. We are not forcing anything to the client, like you have to add each and everything. Okay, so this is the basics of the builder design pattern and where we have to use the builder design pattern. Now let's understand the same thing with the code. So in the code we have taken the example of a burger, okay, where you can create a burger with the different ingredients in it, right? So let's understand that. So let me go to the example here, and you can see that I have created one burger object. Okay, so this is the burger class, and this burger class have these properties. You can see that it has the size of the burger, eggs, extra cheese, mayonnaise, onion, lettuce, etc. Okay, so you can see that these are the properties that they can assign. Okay, user can use to create their own burger. Simple thing. Okay, now you can see that this is a constructor here. Okay, now you can see that this constructor is taking the burger builder as the input parameter, and here I have mentioned that this is to initialize all the fields and to do the validations. So as I explained you earlier, like whatever the validations we have to do, like all these basic properties you need. If you want to create a burger, you need to have the bread itself, right? Without the bread you cannot create the burger. So all those types of validations we can add here, like you need all these properties. If these properties are not there, you can throw the exception. So this is the constructor that we have created, and you can see that this constructor is private. Okay, so user will not be able to call the constructor, but the burger builder class that we are going to create, that will use it. And as I explained you earlier, whatever the builder class would be there, that builder class will be creating the inner class itself directly. Okay, so you can see that for all this fields that we have, for all that fields, what we have done is we have added the values here. We have added the getters. All the getters method we have added here. Simple thing, no setters. Okay. Now you can see that we have created one public static class, that is the burger builder. Okay. So this is the inner class, inner static class. So we can directly use this. Now you can see that within this class we have added the same properties here. Okay. You can see that these are the same properties that we have added in the burger class itself, because we will use that to set the burger properties. Now all these properties are there. Now you can see that to set all these properties, we will be using one method that will return the burger builder itself. Okay, so to set the size, you can see that we created a method that is public, which is returning burger builder itself, and it is taking the size, and we are setting the size within this class, and we are returning this object itself. We are returning the same object, that is the burger builder. Similarly, for setting the egg, we are having the same method, that is the burger builder. It will return the burger builder, it will set the eggs, and it will return the same object. For each and everything, to set all those things, we will have one method that will return the same object itself by setting the values. Okay, so for eggs, for extra cheese, for mayonnaise, for onion, for lettuce, etc. So all the things are set. Now once all the things are set, we will have one method, that is a build method, that will help to create the entire object for us. Okay, so here you can see that we have one method, that is public build method, which is going to return burger. Okay, because this, you can see that this is the burger builder. So we are building our burger, and at the end we have build method that should return me the burger, because that's the end result I want. So once we have this method created, that is public burger build, you can see that what is returning here. It is returning new burger, and the object that we are passing is this. Okay, so the input is this object, that is the burger builder. Now if I come here, okay, here what I can do is the entire burger builder is coming here, right? So here I can do all the validations. Okay, all the validations are done here or not. Okay, if all the validations are done, everything is there what we need, then we can assign all those values to this object. Okay, and return this object. Simple thing. Okay, so whenever I want a burger, I will use burger.burger builder, then I will set all these properties, and I will call the build method to build my object. So this is the simple way you will create a builder design pattern. So now if you are aware about the Gangs of 4 design pattern book, in that there is also one extra thing mentioned, that is the director. Okay, so let's understand that part as well. So here you can see that in the main class, if I go here, okay, you can see that how I will be calling this burger is, so burger equals to new burger.burger builder. I will add mayonnaise, I will add, you can see that I am adding all these values here, right? And at last I'm calling the build method here. Okay, so this, by setting all these values and by calling them build, it will give me the burger here. Now let's understand about the director as well. Okay, so here you can see that I have a meal object. So meal object has few of the properties, that is the curry, bread, cold drinks, biryani, etc. And this have the getters and setters as well. Okay, simple meal object. So you can see that for this meal object, okay, we have all the getters and setters, everything set. Now this meal should also have a builder with which we can create the object, but meal can also be a veg meal as well and a non-veg meal as well. Okay, so if I go here in a meal builder, you can see that this is the abstract class, and this abstract class has all the different abstract methods. Okay, so you can see that it can have add biryani, add bread, add cold drink, add curry method. Okay, all these methods are to add the basic things of a particular meal, and it has a build method which will return the meal as well. Okay, so all these abstract methods we have defined here. Now we can have the multiple classes, that is the veg meal builder and a non-veg meal builder. That two class should implement this abstract methods, so based on that they can assign the values. Okay, so they can create the object. Either if we pass veg meal builder, it should create the meal which is veg meal. If we provide non-veg meal builder, it should create a non-veg meal. Okay, so if I go to the veg meal builder, you can see that veg meal builder is also extending the meal builder, which we have already defined here. So once we extend this, we have to add the implementation of all the abstract methods. So here you can see that we have implementation of all the abstract methods. Okay, but here one thing you can see that we have the object of a meal itself. Okay, because from the veg builder we want to return the meal at the end, right? So that's why you can see that it's going to return the new meal. okay, from this constructor. Now all these methods, you can see that add biryani is adding the biryani, that is veg biryani, add bread is adding the naan, cold drink it's adding, okay, curry it's adding, and you can see it has a build method which will return the meal object. Similarly, if you go to the non-veg meal builder, we have the same thing. Non-veg meal builder is also extending the meal builder, and it has the meal object, and it is going to have all the methods similar to what we added in the veg meal, but the values would be different. Okay, so you can see that now you have two builders available, that is the veg meal builder and a non-veg meal builder. Now as I have two different types of meal created, that is a veg meal and a non-veg meal, whenever any customer asks, okay, I want a veg meal, so by default I should have something that goes based on the value veg and gets all the veg item only. So it will create each and everything, it will add each and everything in a particular object, and it will return me. If someone says that I want non-veg meal, okay, it will add all the non-veg items and it will create a meal and it will give me that particular thing. What I'm talking about, that's called the director. So that director will take the input, okay, and based on that input it will go call a particular builder, and that builder will return the particular meal. Similarly, if I ask the director that I want the non-veg meal, it will go to the non-veg builder. Non-veg builder knows that what we need to add, and it will add everything and it will give me the object. Okay, so that's the job of the director here. So if I go to the meal director here, you can see that meal director has the object of a meal builder. So it knows that what we need to add. So you can see that meal director, okay, there is a constructor here, and this constructor is taking the meal builder object. Okay, and within this meal builder, you can see that it has all the different methods. It is calling all the methods, add biryani, add bread, curry, cold drinks, everything, and at the end it is calling the meal builder.build method. So whenever I will call meal director here and I will pass the proper builder here, suppose in the meal director if I pass veg builder, it will call all the methods of a veg builder and it will create the meal which is a veg meal. If I pass the non-veg builder, it will add a non-veg items and it will give me the non-veg meal. Okay, so you can see that that's the part of the director here. So whenever I want to call it, if I go to the main, you can see that how I'm calling, I want a meal, okay, and I'm calling the meal director. So in the meal director, I'm passing that I want a new veg meal builder. So I'm passing the new veg meal builder. So this is something that it will return the veg meal, and that's why, and we are calling the method after that, that is the prepare meal. Prepare meal is what something where we have defined here, right? And this prepare meal is calling all the methods of a builder and returning the build method. So you can see that that's the part of the director, but don't worry, most of the times you'll be directly creating those builder classes. You will be creating a nested class, and that nested class will be having all the properties and methods to assign each and every value, and a build method to return a main object itself. Okay, so that's how you will be defining a builder pattern, and that's how you should answer in your interview questions as well. Now if you're working with Java and if you know about the Lombok, so Lombok has the annotation that is the @builder. So with that annotation, whatever the class that you have defined, that will be entirely converted into the builder design pattern, and you can use these different methods to create the objects. So that's a very easy part when you're working with Java. You can directly use that annotation from the Lombok to create the builder design patterns. So this is one of the easiest design pattern to create the different objects. So we covered everything about the builder design pattern. It's very easy. If you have any doubts, then do let me know in the comment section below. I will try to solve it as soon as possible. In this video, we are going to learn about the prototype design pattern. So let's get started. Now prototype design pattern is a creational design pattern. So it will be helpful when we want to create the different objects. So let's understand how this will be helpful and where we can use the prototype design pattern. So from the name itself, we can identify that there will be some types of prototypes, and from that prototypes we can create the objects. So suppose in the real world example as well, whenever we are doing any engineering stuffs, right? So what we do is we create some prototypes. So suppose we create some prototype 1, right? Suppose I'm working on a robot, right? So for that robot, I will create one prototype, and on top of that prototype, I will do some modifications and I will create the another prototype for that particular robot. Okay, and what I will do is I will always do some kind of configuration changes or some minor tweaks to create the different prototype out of it. So you can see that I had created one prototype, and on that prototype I did some modifications to create the another object, that is the another robot, and from that another prototype I can create the object to have the another prototype, or I can do little tweaking on the this prototype itself and can create the another objects as well, or another prototype as well. So you can see that based on some base structure, you will be creating the different objects. So that's where prototype design pattern comes into picture. So suppose if you have lots of objects to be created and all those objects are very heavy while creation process. So what you can do is you can create the prototype pattern out of it, and you can create the clone of that particular prototype, and you can do some modifications. Okay, so you can see that we are not doing any rocket science here. Whatever the prototype it was earlier, we did some tweaking on it and then we created the different prototype. So for our objects as well, if I have objects created, okay, and for that objects, what I can do is I can do some tweaking on it and I can create the objects. So when I have to do the tweaking, what I will do is I will clone this entire object, do some tweaking on it, and then I can use that particular object. So that's the idea behind the prototype design pattern. Let's understand more on it. So let's understand with one example here. So what we can say here is, suppose you want to create two-wheelers and four-wheelers, okay, the objects of two-wheelers and four-wheelers. So how you will create the object of those things? So suppose if you have the base thing, so the base thing of a two-wheeler and four-wheeler would be vehicle, right? So you would be creating a vehicle, and with that vehicle either you can create a two-wheeler or you can create a four-wheeler or a car, whatever you want to say, because in two-wheelers also you can create a bike, a motorbike or a scooter. In four-wheelers you can create a pickup truck, you can create the car, so many stuffs. Okay, so that's why we are going with a generic form. Now you can see that what vehicle would have. Okay, so vehicle would have basic things. So vehicle would have engine, what model it is, okay, the price of the vehicle, and lot more. Okay, so you can see that this is your base vehicle. Okay, this is your base vehicle. Now based on this base vehicle, you can either create what type of that vehicle is, either it's a two-wheeler or four-wheeler. Okay, and to have everything added here as a vehicle, it's a complex task, right? Because creating vehicle itself is a complex thing. So what we are trying to do is, rather than creating the object of a vehicle or a two-wheeler or four-wheeler every time, what we can do is we can use the already existing objects, and what we will do is we will clone that particular object and we will do the tweaking on it. So what I want to do is, whenever I want to create the two-wheeler, what I can do is I can define, okay, it has to be a two-wheeler engine, it should have a particular model for it, it should have a price for it. Okay, I can add some more parameters as well here. Suppose is this two-wheeler electric or not, that also I can define. Okay, and so you can see that this is something that is the deciding factor or a change factor based on the default vehicle. So you can see that with this particular change, you can see that you had created the object, but most of the things were similar. Most of the things that you have copied from the vehicle object itself. So what you did, you copied the object here, okay, and then you added some of the properties. Similarly, you can do the same thing over here as well. So in the four-wheeler as well, you can add the engine, you can add the model of that engine, model of the car, the price of the car. Is it going to be petrol car? Is it going to be diesel car? Whatever it is it going to be having the air conditioner or not? Whatever, there are different parameters to it. You can add the different parameters. So here also you can see that few of the things you are taking from the vehicle object itself. You will be cloning this object and you can add the different parameters to it. So you can see that you are using the base object, that is the vehicle object. On top of that, you are doing some modifications. So one more thing we can do over here is we can have the registry of the prototype objects that we can create. So rather than cloning this object every time for a two-wheeler or four-wheeler, what we can do is, I already know what I want to have in a two-wheeler and I already know what I want to have in a four-wheeler. Okay, so those objects as a base objects, okay, these two objects as a base object I can store somewhere, right? And that I can store in the registry. Don't mind my spelling and handwriting, it's really bad. Okay, so just understand that this image and this image, okay, that is the two-wheeler object and the four-wheeler object. Both of them I can store in one registry. Okay, so suppose I can create a vehicle registry, and in this vehicle registry I can store that two-wheeler object and a four-wheeler object, and I can store each and everything in a hash map. And here I can give a key as well. This is going to be 2, this is going to be 4. So now you can see that I have the base object stored in one registry. Okay, this is going to be my registry. Now whenever I want to create a two-wheeler, okay, what I will do is I will clone this object. I will clone this object of a two-wheeler, and whatever the modifications I want to do, I can do those modifications and I can have the object of a two-wheeler. Similar thing, when I want to have the four-wheeler object, I will just get this object, clone it, and I can do the modifications and I can have the four-wheeler object. So you can see that every time I do not have to create the entire object by myself. There is an already object available in the registry, I can use that object and I can do the modifications on it and I can use that object directly. So you can see that there will be a lot of time saved while creating the objects, because these objects will be very heavy while creation processes. Okay, so that's why we are using the prototype pattern. If the object creation is heavy, at that time only we should go with the prototype design pattern, create the prototype of it and clone that particular prototype and use it. Okay, so you can see that the cloning part is really important here. So this is just the high level explanation that I have given you. Let's understand by code as well, like what we mean by vehicle registry, what we mean by cloning and everything. Okay, so let me just go to the IntelliJ IDEA here, and here you can see that I have the prototype project available. Okay, in this prototype you can see that I have given the entire explanation here, and I have also added the reference from where I have took this example. Okay, so you can refer this as well. I will share all the codes with you. So here you can see that I have created a base vehicle here, and you can see that this is the abstract class vehicle, this is the base class that we understood earlier, and you can see that this is implementing clonable interface. So this part is really important, like whatever the base that you are keeping for a client to use, that has to have the capability to clone the particular object. So you can see within this vehicle we have engine, model, price and a constructor which will initiate the object of a vehicle. Simple thing. Okay, one more thing, you can see that as we have implemented the clonable interface, we also have the clone method here, and you can see that what this clone method is doing, this clone method is returning the vehicle object by doing the clone operation. Okay, as we have implemented the clonable interface, we can do the clone operation here, and it will clone the object, convert to vehicle and it will return it. And these all different methods, you can see these are thus the getters and setters for these three values. Simple thing. Now your base vehicle class is ready. Now let's go to two-wheeler vehicle and a four-wheeler vehicle. So if I go to two-wheeler vehicle, you can see that this two-wheeler vehicle is extending the vehicle itself. Okay, and it has one extra property, that is it electric or not. Now you can see that whenever I am creating the constructor of it, what I'm taking is I'm taking the engine, model, price. These three are part of the vehicle itself, and I'm taking the is electric as well. So I'm calling the super and I'm assigning the is electric as well. Simple implementation of the two-wheeler. Similarly, if I go to the four-wheeler vehicle, this is also very simple. Four-wheeler vehicle is extending the vehicle class. It has couple of more properties and it has a constructor to initialize the object and a clone method as well. So whatever classes are extending your base class, all those classes should also support the clone method. Okay, that's the main thing over here. So here also you can see that it is supporting the clone method and it is cloning the object and it is converting to four-wheeler vehicle here. Okay, similarly it has to be in the two-wheeler vehicle as well. So you can see that vehicle, two-wheeler vehicle and four-wheeler vehicle all should have the clone methods. So now all your base classes are supporting clone methods. So whenever I want to get a particular object, I can get using the clone method. Now this was just the basic, like the classes only we created, but now you can see that I have also mentioned the registry as well. So here you can see that we have created the vehicle registry as well. So this vehicle registry, you can see that is nothing but a hash map of string and vehicle. Okay, so you can see that within the starting of the application itself, what I'm doing is I am creating the prototypes and storing in my registry. Simple. So I'm creating the prototype of two-wheeler vehicle and a four-wheeler vehicle. You can see that I'm just creating the object and I am storing all those objects in my registry, that is the map vehicles, and with the key is 2 and the key for the four-wheeler is 4. So you can see that whenever my application starts, I have the prototype objects ready. Now whenever anyone wants to use those objects, they can get using one of the methods that we provide. So here you can see that we are providing get vehicle method from the vehicle registry. So whoever wants a particular object, they can get directly by the value that they pass. So suppose they want a object of a two-wheeler, they can pass 2 here as a string value, and what we will do is we will get a particular two-wheeler object from the hash map and we will clone it and we will return it. Simple. So you can see that from the registry itself, we will provide the client to get a particular prototype object, that is the clone object of a prototype we have already stored. Similarly, if they want the object of a four-wheeler, they can pass 4 and it will clone it and it will return the particular object. So you can see that the objects will be always new created. It will be a clone object created. Whatever the modifications needs to be done, that modifications can do, client can do those modifications and they can use this particular object. So you can see whatever the heavy objects are there that your application needs, all those things can be done directly in the prototype objects that you want, and that they can use by cloning. methods. So you can see that it's really simple method to implement. We just have to identify like when we are using the prototype pattern. Whenever your object creation is very heavy and all the clients are dependent on to have those particular objects, right? All the clients, at that time we will go ahead with this pattern. We will allow them to have the clone objects and they can use or modify those objects according to their need. So this question will be asked a lot in your interviews as well, so don't worry about it. So what you need to make sure is whatever the base object that you create, that base object should support the clonable interface. Okay, that should support the cloning of the object, and whatever the subclasses are there, that also should support the cloning operations. Okay, once you do that, okay, what you can do is like you can create the registry of it, and in that registry you can create those base objects and you can store them, and whenever anyone wants to use that, they can use directly using this vehicle registry or the registry that you create. Okay, one thing is you should not allow the other classes to be used directly by the client applications. Okay, we should allow only by the registry. They can clone those objects and then they can create it. So this way you will explain in your interviews, your interviewer will be happy with your answers. In this video, we are going to learn about the adapter design pattern. So adapter design pattern is a part of a structural design pattern, and as the name suggests, as the adapter, it is something to adapt to a different types of objects that we have. Okay, different types of implementation or the interface that we are working with. For that adaptation, we can use the adapter design pattern. This is one of the easiest design pattern in the structural design pattern. So let's understand more by going through the diagrams. Now, when to use the adapter design pattern? So whenever we want to adapt to the different implementation or the different interfaces provided, at that time we can use the adapter design pattern. So suppose, let's take one example. You have one application. This is the same example that you will see everywhere. So let's use the same example to understand the basics of it here. Okay, and this is the application that you are working with, and you are also working with the third party application. So you will be working with multiple third party applications. So one of the third party application is suppose F1. Okay, and this application is sending you data in the form of XML, and your application is also working with XML data. So that's the one thing. Now you have application 2, that is the another third party application, but this application is working with JSON data. Okay, and from this application 1 you need to send the data to the application 2, but application 2 only works with JSON and your application also works with the XML data. So what you can do, so at that time you can have the adaptation to the JSON data, right? You need to adapt to JSON data from the XML data. So at that time you will add the adapter here. Like it's the same thing, right? Like in India and US, we have the different types of electrical socket, right? So we have to adapt to that different types. So here also it's the same thing, we are adapting to it. So here adapter we have added, and this adapter will take this as the input here. Okay, and it will adapt to the design pattern or pattern that has been JSON data here. Okay, so it will take the input as the XML, it will adapt to what we need to send to the app to, and accordingly it will create the object and it will pass it on. Okay, so all that part you can see that it is done by your adapter. So this adapter design pattern will let you to adapt to the different types of implementation. Okay, so that's why you can see it's a structural design pattern where it is allowing you to change the structure of the different implementation or the different objects here. So let's take one more example. Let's take the example of a Swiggy here. Everyone will know that what is Swiggy. Swiggy is a food delivery application. Okay, so what it does is it will deliver food from the different restaurants. My spelling is really wrong, let me correct it. Okay, it will deliver the food from the different restaurants to you. So that's the work of a Swiggy application. Okay, so let's understand more what it does is. So what Swiggy will have is Swiggy will have an item to be delivered, right? So it will have the item class, and this item class, what it will have is it will have item name, the price of the item, and the restaurant name, right? From which restaurant we can send it. And this item will be the interface, and this item will be implemented by the food item, and this food item will be the implementation of the item, and it will have the same thing like food item name, the price of it, and the restaurant. And Swiggy store will have the list of item in the store, and any item we can order and that can be delivered. Okay, that's the entire Swiggy store working. Now at the time of pandemic, Swiggy decided that let's deliver the grocery items as well. Okay, because we are already delivering the food items, and due to pandemic that is not possible. So now we have to deliver the grocery items. Now grocery item is completely different from the food items, right? So you can see that now we have the different implementation, that is the grocery now. So within this Swiggy app, now we have to send the groceries. Now groceries is completely different, so we need to adapt our application to send the groceries as well. So what we can do is we can have the adapter here, so that it will convert all the groceries items into the item that we have, right? This item. It will convert the grocery items into this item using the adapter, and that we can list in our Swiggy store and anyone can order it. Okay, so you can see that it's a classic example of the adapter design pattern. Now what I can have is I can have the grocery item created, and this grocery item, what it will have is it will have the item name, okay, grocery item name, the price and the store. Okay, because grocery you can purchase from the store, not from the restaurant, so that's the different here. Okay, so that's why it's not able to adapt to it. So now this grocery item interface will be implemented by the grocery product, and it will have the implementation, it will have the item, price, store and everything. Now whenever I want to list all these items, I need to have the adapter. Okay, so if I create the adapter here, that is the grocery item adapter, so what it will do is it is going to implement item here. Okay, so it is going to implement item here. So now you can see that grocery item adapter is implementing item here. Okay, so at the end all the methods will be of the item, but it should have the object of the grocery item. So whatever the methods are there of the grocery item, okay, so it will convert all those values, all those behaviors to this item. So at the end it will return the item. So you can see this adapter, okay, is implementing the item here, but in the meantime what it is doing is whatever the grocery item it is changing this grocery item into this item. Okay, so it is adapting this grocery item to this item here. It's doing the simple thing. This adapter is doing simple thing like taking this grocery item and converting this to item. So this item is something that we can add in our store, right? So that's how this adapter design pattern will work. Let's understand with the code as well. So we'll take the same example here. So here you can see that I have the item interface here. Okay, you can see this is my Swiggy store, and you can see in this Swiggy store I have listed all the items here. Okay, I have the list of items, and all the items I can add to my store using the add items here. Okay, that's a simple store. Now everything I am working with the item here. Okay, so you can see I have the item interface, and this item interface has few of the methods, that is the get item name, get price and get restaurant name. Okay, three things. Now this item is implemented by the food item because we are serving food here. So if you go to the food item here, food item is implementing item, and it has all the items here. Okay, currently I have just implemented with null here, but this is something that it will be implemented and it will be visible in your store. Now as we discussed that, now we want to add the grocery item as well. Now grocery item, you can see it's completely different from the item that we have. So it has name, price, but it has a store name rather than the restaurant name. Okay, so you can see that these are different things here. Okay, so you can see these two are not compatible currently, but we need to make sure that both are compatible. So this grocery item is an interface, so there has to be one class which is implementing it. So we have the grocery product here. Okay, which grocery product is implementing the grocery item, and it has all the methods implemented. Simple thing. Now as I want to add my grocery item as an item here, I need to have the adapter here which will adapt my grocery item to the item that I want to add here. So I have created one grocery item adapter here. Okay, so you can see this is a class grocery item adapter which is implementing item. So that means whenever I'm implementing item, all the methods of the item interface I need to write it here. So this items interface has all these methods: get item name, get price, get restaurant name, everything. Okay, so I have implemented all these methods. And one more thing, you can see that I have the property of the grocery item as well. So I have the instance of grocery item here, and whenever I have the constructor, whenever I am creating the object, I will take that grocery item here. Okay, and this grocery item, you can see that I am passing here. So now you can see that whenever I'm calling this get item name of the item, I am passing the item name of the grocery item. Similarly, price, I can directly give the price, and for the restaurant name I am giving the store name here. So you can see that I am adapting everything here. So for the food, it is restaurant name, but for the grocery, it's a store name. So whenever I'm calling get restaurant name for that particular grocery item, I am using the store name to pass to the restaurant name. So you can see that I'm converting store to the restaurant here. Okay. Similarly, I'm converting grocery item to the food item. So you can see that this is the adaptation that we are talking about. So you can see that this adaptation class that we create, that is using the adapter design pattern. So now if I go to the main method, you can see that in the Swiggy store here, I can directly add the food items here, right? I have directly added food items. Now, whenever I want to add the grocery item, you can see that I'm calling the grocery item adapter here and I'm passing the grocery product. So it will convert this grocery product into the item with the grocery item adapter. So you can see that how simple it is to adapt to the different implementation or the different interface that we have in our application. So this is one of the easiest design pattern in the structural design patterns, that is the adapter design pattern. So whenever interviewer is asking you about the structural design pattern, then this is something that you can always tell about the adapter design pattern, that you can explain this because this is the easiest one to start. So go through this code as well. I will share you the code as well, code link in the description below, so you can check this out. It is really easy to implement as well. And if you have any doubts regarding any of the things that we have covered, then you can always ask me in the comment section below. In this video, we are going to learn about the bridge design pattern. So let's get started. Bridge design pattern is a part of a structural design pattern and it will help us to create a structure for our different classes. Now, how bridge pattern is useful? Now, whenever we are working with a huge classes and a huge subsets of classes, and at that time, if you want to divide into separate hierarchies for the abstraction and the implementation, at that time we can use the bridge design pattern. I know the definition is quite confusing, so let's understand with example. So let's take the example and understand how the bridge pattern is helpful for us. So let's take the example of a video and video processing. So in the YouTube as well, you can see the video. In the Netflix, you can see the videos. So let's take that example. So currently you can see I have the video object here, video class, and this video class you can see I can divide into multiple classes. Suppose I can say this is a YouTube video, I can say this is a Netflix video. And within the YouTube and Netflix, you have different options as well. You can play the video in HD, 4K, 8K, same with Netflix as well. Okay. So what you will do is, if you want to have that functionality, you will create the subclasses, subtypes of that as well. So you can create YouTube with HD. You can create YouTube with 4K. You can create YouTube with 8K. Similarly, you can create Netflix with 4K and Netflix with 8K. So you can see that by just adding the different type, you are exponentially increasing the subclasses. Suppose now if you are introducing the Prime Video as well, so for that as well, you will be adding the different subclasses like Prime Video HD, Prime Video 4K, Prime Video 8K, and so on. So you can see that whenever you are onboarding anything, you are creating a huge list of subclasses. So that is not ideal. You are just creating the classes exponentially. So what we can do to avoid that? Okay, so at that time, bridge pattern comes into picture. So what bridge pattern will allow us to do is, it will allow us to convert this entire is a relationship, right? This is the entire is a relationship, that is the inheritance, right? It will allow us to convert this entire into a composition, that is a has a relationship. So let's understand how this entire thing can be converted into the has a relationship. So let's take the example here. Okay, so what I will have is, I will have the video here, okay, video class, and this video class will have YouTube here and it has Netflix here. Okay, you can see that we have the simple hierarchy, and if I want, I can add the Prime Video as well here. So you can see that I have the standard classes available here, and now what I want to do is, I want to separate out the hierarchy, right? Because I want to convert the inheritance into the composition relationship. So what I will do is, rather than creating the HD YouTube, 4K YouTube, and similarly, I will create the processing classes separately and I will create a has a relationship. So here you can see that I can completely create a new hierarchy, that is the video processor. And this video processor, you can see it has HD processor, it has 4K processor, it has 8K processor, it can have HDR, whatever it is. Okay, so you can see that we have this processing available, that's a video processor. Now what we will do is, we will have the composition relationship, okay, for this video, that this video will contain the video processor. Okay, so now video will have the relationship with the video processor. That video will contain the video processor. So whenever we want to create the processing for a different pipeline for the different types of videos, we can do similarly. Like for a YouTube video, I can have the object of a video processor and I can create YouTube video with HD, YouTube video with 4K, YouTube video with 8K, similarly YouTube video with HDR as well. Similarly for Netflix as well, I can do the same thing, Netflix HD, Netflix 4K, Netflix 8K, similarly Netflix HDR as well. So you can see that I am not creating the complete hierarchy, but I have the two separate hierarchy and I can create the objects which has the contains relationship. Okay, so whenever I want to create the object that Netflix object with the 4K, I can create it easily. So this is the general idea about the bridge design pattern, as this video processor, which is the instance available within this video, will work as a bridge between that and the video processor. Okay, so that's why this is known as a bridge design pattern, because it's working as a bridge to have the different of the video classes itself. Okay, like video HD, 4K, 8K and HDR, similarly others as well. Now this is the simplest example that I have shown you. When you go through online, you will get a more complex examples as well. Okay, but if you want to understand the theoretical part as well, I will include the theoretical part in my code as well. Okay, so let's understand with the code. So if you go to the IntelliJ IDEA here, okay, this is the bridge pattern. This will be available in the repository. And if you go to the main method, you can see that entire documentation, entire theoretical part I have mentioned here. Okay, and I've also mentioned from where I have taken the references. So you can go through their websites and you can support them as well. So all this implementation, all these details are available here. Let's understand with the video here how this will work. So whatever we explained here, whatever we understood here, the similar thing we have created here as well. So you can see that we have the video interface created, abstract class, sorry. So you can see this video class, this is the hierarchy 1, and video processor, this is the hierarchy 2. So if you go to the video processor here, right, this is the another interface and this is the separate hierarchy. So video is one hierarchy and video processor is another hierarchy. And you can see that multiple hierarchies we can use using the composition relationship. So that's the idea here. So within this video class, you can see that I have the object of a video processor. Okay, and within the constructor, you can see that I am taking the video processor object and assigning the value here. So for this video, I have the processor and I have the abstract method play, which will take a video file and it will play it based on the video processor that we have. Okay, so suppose this video have the HD processor, then it will be playing HD. If this video has the 4K processor, it will play in 4K. If it is 8K, it will play in 8K similarly. Now from this video, okay, we have different classes created. So here you can see that we have a Netflix video, which is extending video, and it has a constructor and it is calling the method play. That this play method will be called and processor.process it will call. Okay, similarly, if you go to the YouTube video is also extending video and it has a constructor which is taking the video processor and it is implementing this play method. Okay, so you can see that whatever we have defined here in the video, that play method we are defining. Now if you go to the video processor, okay, it has a process method. So this video processor is been implemented by HD processor. You can see that HD processor is implementing video processor and it has the method implemented, that is the process. Similarly, if we go here UHD 4K processor, it is implementing video processor and it is also implementing the process method. Okay, so now whenever I want to call a method, call this object. So if I go to the main, it's simple. You can see that I want a YouTube video. So I've just created the object video. YouTube video equals to new YouTube video because I want YouTube video, and we have to pass the processor. Which processor? I'm passing the HD processor. So this object, you can see that it will play YouTube video in HD. And if I call YouTube video.play and the file, this will be played as HD video. Similarly, if I see, you can see Netflix video is there, that I am creating the Netflix video object with the 4K processor. Okay, and now whatever the video this will be played, it will be played in the 4K. So you can see that we just converted the huge subclass library exponential classes into two different hierarchies and converted into has a relationship. In this video, we are going to cover the decorator design pattern. So let's get started. Now, decorator design pattern is a structural design pattern which will help you to add the behavior of one object into the spatial wrapper which will add the another behavior of the same object. So it is like the box inside a box inside a box inside a box, right? So this is the decorator design pattern. So let's understand when we use decorator design pattern and how it will be implemented. So suppose, let's take the simple example. This is the same example that you will see everywhere when you are understanding the decorator design pattern, but it is a very important example because it's very simple as well. So everyone, we know that we love pizza, right? So whenever we are going to have a pizza, we have the different options available. So let's understand with the same thing. We have the pizza class here, and this pizza class, you can see we have the base pizza available for this. Okay, that we need a base pizza. Now on top of this base pizza, you can have different n number of pizzas, right? So you can have the veg pizza, right? You can have veg pizza plus extra cheese. You can have non-veg pizza plus cheese plus jalapeno. You need veg pizza plus extra mushrooms plus extra cheese, right? Plus extra tomatoes. You can have n number of different toppings available, and based on all these different toppings you can create the different pizza. But you can see that for this I am creating a lot of different classes here, right? That is not ideal when we are working with the application, when we are working with the object oriented programming. It is not feasible to have a lot of different classes for the same reason, right? You can see if we have 10 different toppings available, right, then how many classes that we will create? There is a lot of permutations and combinations available, so it's not feasible. So we need to come up with an approach that we can use all these different behaviors, all these different classes, and we can create a different behavior. We can add the different behavior on top of the existing class itself. So if I have the pizza and if I add extra cheese, that itself will return me the pizza. That itself is a pizza but with extra behavior. On top of that, if I add extra tomatoes, then itself it is a pizza but with another behavior. If I add another extra cheese, right, then it's again a different behavior but with the same class, with the same pizza, right? So you can see that it is just changing the behavior but the base class is the same. So how we can achieve this? Like we can convert or we can change the behaviors but the base is always the same. It will return the same thing. Okay, so for that we can use the decorator pattern. So decorator pattern will allow us to decorate any of the particular class. It's like adding the toppings on top of the pizza, right? Like you have the pizza, you will decorate it and you will add some toppings. On top of that you will decorate it and you will add some more toppings. On top of that you can again decorate it, that is adding some more toppings. Okay, so let's understand how we can achieve this. So what we will have is we will have the pizza class available here, pizza interface. Okay, and this is going to be the interface. So anyone can implement this interface here. So it will have the method. Suppose it has a bake method that we need to bake the pizza. Okay, so suppose there is a base pizza class available. This is a base pizza which will implement pizza here, and it will have the bake method implemented. Okay, this is the base class. Now suppose I want to have the decorator. So what I will do, I will create a pizza decorator class. So I will create a pizza decorator class, pizza decorator, which is going to implement pizza, right? Because at the end it is a pizza. And what I will do is this pizza decorator will have the instance of pizza class, and we will have a constructor, and within this constructor we will pass the interface. We will take the pizza interface here, and whatever the pizza interface we pass, we will assign it over here. Okay, from the constructor we will assign it over here, and it will have the bake method also, right? Because we need to implement the bake method which is coming from the pizza interface. Okay, now this pizza decorator can be extended, can be subclassed by multiple. So suppose if we have extra cheese, right? So extra cheese can extend pizza decorator, and it will add the cheese here. Okay, it will, this also will have the object of a pizza, and it will add the pizza over here using the constructor, and within the bake method it will add pizza, whatever the super class will have, plus extra cheese. Similarly, if we have extra mushroom, then that is also going to extend the pizza decorator, and it is going to add extra mushroom in the bake method. So you can see that all these decorator are nothing but a same returning pizza but adding some of the extra behaviors to the bake method which we have extended from the pizza itself. Okay, so you can see that everything is similar, everything is returning the same thing here. So this way we can have the decorator implemented. It's just the same thing, like it is going to at the end return the same class available but with a different behavior. So let's understand more with the code. So if you go here, so here you can see that I have the decorator project available, and within this decorator you can see I have one interface, that is a pizza. Okay, and this pizza interface you can see it has one method, that is the bake method. Okay, now this pizza you can see that it is been implemented by base pizza. Okay, and we have implemented this bake method which is returning the base pizza. Simple thing. Now you can see I have created a pizza decorator class. This is an abstract class which is implementing pizza. Okay, now you can see I have the instance of a pizza interface here. Okay, so you can see I have the pizza interface, and using the constructor I am assigning the object reference here. So whenever whatever the pizza I'm passing here from this constructor method, I have that object, and as we have implemented pizza, I have to override the bake method, and you can see that within the bake method I am just returning the pizza.bake. So whatever this method, whatever this object is, that's bake method I am returning. Now this class is going to be implemented by the different decorators we have. So you can see we have the jalapeno decorator. Okay, this jalapeno decorator you can see that it is extending pizza decorator. It has the constructor which is taking the pizza object as we seen in the pizza decorator, and within this bake method you can see that it is returning the pizza plus add jalapeno. Right, similarly if you go to the cheese burst decorator, it is cheese burst decorator, right, and which is extending the pizza decorator. It has the constructor, and in the bake method you can see it is returning pizza.bake plus add cheese, this add cheese method. Okay, so you can see that we have the n number of decorators available, and at the end it will return the same thing. Okay, so now how we can call this? So for calling, if you go to the main class here, so you can see that I want pizza from what? I want pizza from base. Okay, main base. Now that main base I can decorate it. Okay, I want to add the cheese burst, okay, pizza. So this you can see that this base pizza is decorated by the cheese burst decorator. You can see that this is the decorator on top of the base pizza. Okay, now on top of that cheese burst decorator I want to add the jalapeno as well. So that entire thing is now again you can see is decorated by the jalapeno decorator. Okay, so you can see that on top of that again it is a jalapeno decorator, but at the end jalapeno decorator is implementing the pizza interface, so at the end this is going to return pizza itself. Okay, so if I want to again decorate with something else, I can again on top of that decorate that particular class. So you can see that this is going to return pizza plus this is also going to return the pizza plus this is also going to return the pizza itself. Okay, so everything is going to return pizza. So we have the pizza object and we can bake the pizza object. So if I run this, so you can see that I am getting the base pizza, cheese and jalapeno. So this way you can see that we can add the different decorators based on the different classes that we have. Okay, so we can create a number of decorators, and you can see it's really easy to implement. What you have to do is you can have the base class ready and you have the different decorator which is implementing that base interface, and it has the object of the same thing, and you can always have those methods and return the same thing. And within the constructor you have to take the same base class object. So this is also really simple structural design pattern to implement, and if you are asked in the interview you can go ahead with a simple example. If not the same example, you can always prepare your particular example before interview, and that you can explain in your interview process. Okay, make sure that you have couple of different examples ready when you're going for the interview. If you are explaining any design pattern with one of the example, if interviewer may ask like give me some other example or real world example, you can go ahead with that approach as well if you have prepared for it. Okay, so make sure that you prepare different examples for different design patterns. So that was all about the decorator design pattern from the structural design pattern type. If you have any doubts regarding any of the things that we have covered, then do let me know in the comment section below. In this video, we are going to learn about the facade design pattern. So let's get started. Now, facade design pattern is a type of a structural design pattern which will allow us to structure our application. Now, whenever you are working with any third-party applications or any libraries, sometimes that library is huge and complicated as well. But you need to have some of the functionalities from that particular library. So rather than using that entire library, what you end up is you create a small class, and that class is a helper class, you can say, that will help you to use that particular library. Okay, that's nothing but a facade design pattern. So let's understand a bit more about the facade design pattern and how we can implement it. As I explained you, let's take one of the example here. Suppose you have a library called video processor or a video encoder. Okay, there is a library called video encoder, and this library provides a lot of things. But what you need from your side is, from your application, okay, from your application, you just want to upload one video, and that video should be encoded in HD. This is your standard application. Okay, this is the standard processing that you need, but you don't need a lot of functionalities provided by the video encoder library. That's a full-fledged library. You just need a particular information, and that you can implement it easily. So what you can do is you can create the interface or abstract class, abstraction layer on top of it, which will allow us to use this video encoder library. Suppose app video encoder, okay, which will use this library internally, but it will provide us the interface or abstraction where we can use, suppose, encode video, which will take the file here to encode a particular video. So you can see that we are just adding one abstraction layer, and that abstraction layer will help us to reduce a lot of complexities of the other framework or a library that we want to use. So whenever you have such scenario where you want to reduce the friction to use the other library or to have the abstraction on top of that particular library, at that time we will use the facade design pattern. So this type of pattern is widely used in the industry. We might be using it, but we might not know as well, because we generally do a lot of things. We create an abstraction on top of the other libraries that we want to use, and at that time it is easy for us to implement that as well. So that's called a facade design pattern. Let's take one more example here. Suppose we have the Zomato store. Okay, so Zomato is a food delivery app. Okay, with the Zomato service we can order the food, and a delivery person or a delivery partner will get a food from the restaurant and it will deliver to us. So you can see that ideally you are ordering a food from the restaurant, but here Zomato is your facade in between, okay, which will help us to order a particular food from the restaurant, and a delivery partner will take that food for us and it will deliver us. So here you can see that Zomato is responsible. It's the abstraction where it will help us to do a lot of process. It will help us to order food. It will also intimidate the restaurant that you need to prepare this food. It will assign a delivery partner as well, and delivery partner will get that particular food delivered to us. So a lot of things happening, and you can see that there are a lot of things involved as well, but Zomato will have the abstraction and it will simplify everything for us to order a food. So that's how facade will help us. So let's take the same example, the Zomato delivery app example, and see within the code as well. It's really going to be very easy. So if I go to IntelliJ IDEA, okay, you can see that I have the facade design pattern here, and I have the main class. If you want to go to the theory part, I have added the theory as well, and I have added all the information from where I have taken the references as well. So all the information you will get from here. I will add the link in the description below for you to check. Now you can see that I have the restaurant class available here. Okay, so you can see there is a restaurant class, and this restaurant class is responsible to prepare my order. Okay, so that's one thing. That's the one responsibility of the restaurant class. And you can see there is a delivery team class as well. Okay, this delivery team class's responsibility is to assign a delivery boy. Okay, so that's the one responsibility and one particular class. And there is a delivery boy as well class, which will help us to pick up the order from the restaurant and deliver that particular order to the customer as well. So you can see that we have the restaurant class, we have the delivery partner, delivery team, and a delivery boy as well. So all this information is available. Now what Zomato Facade will do is, Zomato Facade will have the responsibility of the restaurant, delivery boy, and a delivery team as well. So it is going to have the abstraction on top of each and everything, and with one method it will allow us to do all the things. You can see that it is preparing the order, assigning a delivery boy, pick up order, and deliver order. So all this information is been done by one abstraction layer. So this is how you will be implementing the facade design pattern, where you will create the interface or abstract class. You will provide the interface so that it will be easier for us to implement the different applications or different libraries or frameworks. So you can see that this is very easy to implement, and this type of things we would have done a lot in our applications as well. In this video, we are going to learn about the proxy design pattern. So let's get started. So proxy design pattern is a part of a structural design pattern which will allow us to create a proxy object or a reference object to an actual object that we can use easily without having too much load on the actual objects. Confusing, right? But it's really easy. Let's get into the example and let's understand more about the proxy design pattern. So let's take a real world example and understand from it. So whenever we go for a shopping, we have to pay for the things that we have purchased, right? So for that, suppose I am creating the application, or let's take the real world example that whatever you will purchase, for that you will do the payment, right? So consider this is the payment interface, and this payment interface will have the payment method, like pay method, okay? That I'm going to pay. Now ideally, whatever the payment you do, that has to be within the cash, right? But it is not necessary that you have to pay via cash only. You can pay via credit card, debit card, UPI, or whatever the different payment system available, right? Suppose you say you are paying using the credit card. Suppose you say you are paying using the ATM or debit card. Suppose you are doing online transaction, like you can see that you are doing a lot of different methods, or you can do cash as well, right? At the end, all the transaction is a proxy. All these are a proxy for a cash system, right? At the end, everything is a cash, right? Because whatever the money we pay, that represents the cash, right? So at the end, you can see that everything represents the cash, but these are all the proxies of a cash. Like rather paying cash to the shopkeeper, what you do is you use the credit card to pay to that particular shopkeeper, and you are happy that you do not have to carry all the cash and go for the shopping. And the shopkeeper will also have the benefit, like they don't have to take the cash and go to the bank and deposit the cash as well, right? So that's a win-win situation, and you can see that that is possible using the proxy object, that is the credit card or a debit card or any online transaction that you do, right? So you can see that there is a lot of complexity resolved by just using the any proxy things available within the system. If I take one more example, okay, if I take the bank account here, suppose what you do in a bank account is you deposit the money, okay, or you withdraw the money, and you can check the account as well, okay, check account information. All the things you can see, all these particular things, depositing money, withdrawing money, checking the account balance and everything, that you can do by visiting the bank for your bank account, okay? But the similar thing you can do using the proxy of the bank account, that is the ATM. You can go to the ATM and you can withdraw the money, right? And you can check the account balance. For depositing the money, you can go to the deposit machine and you can deposit the money as well. So that's the another proxy for the bank account. At the end, you can see that it will have, or it is the implementation of the bank account itself, because from your bank account only you are getting all this information, you are withdrawing the money. But that's a proxy object for you, right? You do not have to directly go to the bank. You can go to the nearest ATM and you can get those information. So that's a proxy thing for you. So it's just a feasible thing that allows you to not go directly to the main object, not go directly to the bank itself, right? So that's the proxy design pattern. So this is how we will be implementing the proxy design pattern in our example as well. So let's take the same example of a bank account and ATM here, and let's see how we can easily implement it. We can implement using the interface here. So let me just give you a brief of that as well. So if I go here, I have created the folder for the proxy design pattern. I will share this with you in the description of this video, and here you can see that I have added the theoretical part as well and the references as well from where I have taken up this example. And here you can see that I have the account interface available here, okay? And this account interface, you can see that it has two methods. One is withdraw method and one is get account number method. Two simple methods are there for your account interface, and this account interface is being implemented by the bank account. Now bank account is implementing the account, which will force us to implement these two methods, that is the withdraw and the get account number here. These two things are implemented here. Now what I'm doing is I am creating the proxy object. This proxy object should also be implementing the account interface here, and that proxy should have the actual object itself when it wants to refer, okay? That's the ideal definition. So if I go to the ATM, you can see that ATM is implementing the account here, okay, as this is the proxy of a bank account, okay, and it has the object of the bank account here. So you can see that though it is implementing the bank account, it has the object of a bank account because it's a proxy for the bank account, and you can perform the operation on that particular bank account, okay? So rather than directly calling the bank account, you can directly create the object of the ATM and do the same operation, and within that operation you will have the actual object that will do the operation for you, Okay, and now you can see that I've added that you can do all the access controls, validation check, pin checks and everything here. So that extra things also you can do, or you can add on top of the actual business logic. Okay, so all those things you can do with the help of the proxy design pattern, with the help of a proxy object where actual call is been delayed until and unless you actually need it, right? So until and unless you are validated when you go to the ATM, until and unless you are validated with your PIN details, your account number and everything, it is not ideal to get, or it is not ideal to connect to the bank to withdraw the money, right? So till that part, all the process has been done here, and then the bank account object is created and the withdraw method has been, or withdraw behavior has been called for that particular bank account. So you can see that the proxy object will help us a lot in optimizing our application as well. So this is how you'll be implementing the proxy design pattern. I'm trying to make it as simple as possible. I'm not using any complex examples or anything. I'm just using very simple examples, so you get the gist of it, you get the understanding rather than how complex it can get, right? So that's why I'm trying with the simple examples here. If you're still facing any difficulties, then do let me know in the comment section below. I'll try to help it out as soon as possible. In this video, we are going to learn about the composite design pattern. Composite design pattern is a part of a structural design pattern which will help us to create a structure of the application itself. So let's understand where composite design pattern will be helpful and how we can implement it. So let's take a simple example here. Let's take the example of a ordering system, where what you can do is you can order some system, and when any order is there, what you have to do is you package those orders into different boxes and packages and everything, and you ship it. Okay, so suppose if you have item 1 available, and this item 1 can be packaged in a box, okay, maybe small box, and we have the item 2 available. Okay, this item 2 can be packaged in a medium size box, and suppose you have item 3 which can be boxed in a large box. Okay, packaged in a large box. Now when you're packaging, what is happening is when you are adding item 3 into a large box, there is a space available where you can fit a small box itself. Okay, so what you do is you have a large box available, and within this large box you add the item 3 as well, and you add the small box as well. So you can see that you are adding a box inside a box, and within the box you may have an item as well. Okay, so within the box you can add the item, or within the box you can add the box which also has the item in it, right? So you can see that there is a hierarchy creating over here, right? You can add a box inside an item as well, or directly inside a box you can add the item. Okay, so here you can see that it is a composite relationship. Your box can contain item as well, or your box can contain box as well, smaller box as well, which itself can contain item. Okay, so when you have this kind of relationship, at the time we can implement the composite design pattern. So there are 3 components within the composite design pattern. That is component itself, that is a base component, leaf, and a composite itself. Okay, so base component is the actual base component which you can refer to, which you can refer as an object. So here you can see that here we have base component as the box here, right? So here within the box and item, we can represent this as a base component, but leaf would be the end component. So my item would be my leaf component. So after the item I cannot add anything. If there is a box, I can go inside and I can check, okay, within the box there is item, but within the item there wouldn't be any box. Okay, so that would be my leaf item. The other thing is the composite item. So what composite will be doing is composite will have the behaviors to add a base component and a leaf component to have the operation to add a component or to delete a component within the composite itself. So it may have a method to add a item inside a box, or add a box inside a box, or remove as well. So this is something will be used by a client to do all the operations within the entire composite design pattern. Okay, so this is the basic example that I've explained you, like when we can implement the composite design pattern and what are the basic components to implement in a composite design pattern. Similarly, let's take one more example of a department. So here what I can have is I can have a department here, and within this department I can have multiple departments. I can have a financial department, right? I can have a sales department, I can have IT department, HR department, and so on. And for all these departments, I can have a head department as well, right? So within this head department, multiple departments can come in. Okay, so within this head department, suppose there is a financial department, there is a sales department, or HR department. Okay, anything. So here you can see that within the department there is a head department, and within that head department there are different departments as well. So here you can see there is a complete hierarchy forming, and complete composite relationship is forming. So here as well we can implement the composite design pattern. So let's see with the code example here. So here you can see that this is the example that we are working with. Here you can see that for our base component we have created the interface. For your base component it should always be an interface or an abstract class so that the behavior can be implemented by the concrete classes. Okay, so that's the first thing that we have to implement. And I have also added the theoretical part as well, like what composite pattern is and what are the different components, and I have also added the references as well from where I have taken this example, so you can refer to them as well. So here you can see that I have taken the example from the Yugen's website, and it was a very simple example. Here we have created the interface, that is a department interface, which is our base component, and it has a method that is the print department name. So your base component is ready. Okay, now let's create a leaf component. So your financial department, okay, financial department, you can see we created as a leaf component where it will be the end of the department. Okay, so here you can see I have created a concrete class that is a financial department which implements department as a base interface, and I have created couple of properties here, that is the ID of the department and the name of the department, which will have the constructor to populate the details. And you can see we are implementing the print department name behavior, that is a method available in the department interface, which in case it is just printing the name. Simple. Okay, we have the sales department as well. For the sales department we have still implemented the department base class, base interface, sorry, and we have the same couple of properties, that is the ID and name, which will have the constructor to populate all the details, and we have implemented the print department method which will print the name of the class. So you can see that we have two classes, that is the financial department and sales department, which are implementing department interface. So your two classes are created. Now let's see the composite part. You can see that I have created the head department here. Okay, so this head department is also implementing the department, that is the base interface for us. Okay, that is the base component for us. But you can see that we have the properties same as what we have for the leaf components. Okay, that is the ID and name. But alongside that you can see that we have the list of department as well, that is a child department here. And to handle this child departments we have the method, that is the add department and remove department, to add or delete the list here. Okay, add or delete the item from the list. That's what we talked about here, right? We will have the methods to add or remove the items from the composite. Okay, so we have those items here, and we have implemented the print department name method here. And what we are doing is we are going through all the departments here and we are printing the name. We are calling those departments methods. Okay, so that's what we are doing here. It's a simple thing. Okay, and for the add department we are just adding the department what it is passed, and for removing we are also removing the same department which is passed from the list. Simple methods, add or delete from the list. This is the constructor. What it is doing is constructor, it is taking the integer and name and it is assigning the values, and it is creating the new list over here. Okay, simple. Now how we will call it? So if I go to the composite application here, okay, you can see that within the main method I have created two departments, that is a sales department and a financial department. Department sales department equals to new sales department, and I have passed ID and name here. Similarly I have passed for the financial department as well. So you can see that my two department is created. Then I created the head department. So within the head department I passed the head department. Now with the help of two add methods that we have added in the composite class, that is this head department class, I have added this to sales and finance department. Okay, these two objects I have passed here, so those two will be added in our list. And with the head department print department name method we will be able to call this. So if I run this, you will be able to see that we are getting the financial department and sales department printed. So you can see that sales department and finance department has been printed here. So you can see that we are giving the access to the composite here, and with that composite client will be able to use this composite design pattern. It will be able to add the base classes as well and the leaf classes as well, whatever is required in our application. So whenever you have this type of problem where you will be able to add the child as well, and those child can be your base as well and a leaf node as well, at the time we can implement this composite design pattern, and it's a part of structural design pattern. So you can see that it's really easy to implement. You might have implemented multiple places as well, but you might have not know that this is called a composite design pattern. In this video we are going to talk about the chain of responsibility design pattern. So let's get started. Now chain of responsibility design pattern is a part of gangs of 4 design pattern, and here we are going to understand when to use the chain of responsibility design pattern and how we can implement it. It is really easy to implement. So let's go ahead and understand the problem here. So suppose you are working on the ordering system, and what you have to do is you have to get the request here, okay, request for the order, and you have to process the request. That's your goal. Okay, that's a simple thing. And what comes in between is, suppose you have to add some of the validation. So you have to make sure that whatever the request comes for the ordering system, those are properly authenticated. So you add the authentication part as well between the order processing and the request that comes in. Okay, so after some times you also add that, okay, whatever the process is coming, that also has to be properly authorized. So a proper request has a proper authentication, proper authorization or not. Is the request by a customer or is request by admin or not, that you have to identify, and accordingly you have to do some processing on it. Okay, so you add the authorization as well. After that, after some times you get a new requirement to add some of the validations as well. So you go ahead and add some validations, and after that your system is really working well and you are getting a lot of orders to get processed. So what you try to do is you add a caching system as well. So suppose you are adding a caching to this particular system, and you are adding bunch of more different things just before processing your order. Okay, so you can see that this is a lot of details that you are adding here just before doing the processing. Just to process your order, you are adding a lot of different things, right? And sometimes that also happens that some of the validations or some of the processes you don't need as well. So suppose sometimes you don't need validation, suppose sometimes you don't need caching as well, but still you do those cachings and validations and all those stuffs and bunch of other details or other processes that you have added in between the actual processing of the order. Okay, so you can see that this type of scenarios occurs very frequently as well. Okay, so to avoid this problem and to avoid unnecessary calls, right, what we can do is we can add the chain of responsibility design pattern. What chain of responsibility design pattern will do is it will have a appropriate task for doing appropriate things. It will have authentication, will have just to do authentication, and after authentication you can tell, okay, once the authentication is done you can move to authorization. So you can see that you are passing the request and a data from one responsibility to the another responsibility. Once the authentication is done, and if the user is customer, then you have to do some other stuffs. If the user is admin, then you have to do some other stuffs. So you can see that there is a bifurcation there, but there are other stuffs you need to do, right? So based on that, based on some conditions or based on some logic, what you can do is you can again process those different conditions, different responsibilities, right? If it's a customer, there is a different responsibilities needs to be done. If it's an admin, there is a different responsibilities that you need to done. So with that, what you can do is you can define different responsibilities, and those different responsibilities will be passed along the request and those operations will be performed. Okay, suppose caching is not required in admin, then you will skip the caching for the admin. Okay, you will not pass that responsibility, the next responsibility that needs to be completed for the admin role. If it's a customer, caching is needed, so you will pass that caching as the next responsibility for the request. So you can see you are adding the responsibility, a chain of responsibility to be completed alongside the request. Okay, so because of this chain, this pattern is called as chain of responsibility. Okay, so rather than doing this, what you will do is you will create a request, and this is your process, right? And what you will do in between is you will add responsibility 1, responsibility 2, responsibility 3, responsibility 4. Okay, all these responsibilities you will add, and alongside this request you will pass all this data to all these responsibilities, and whichever responsibility you're passing next, those responsibilities will be executed and your entire process will be completed. If some of the responsibilities not needed, you can skip those responsibilities as well. Okay, so that's the general idea about the chain of responsibilities and pattern and where you can implement it. Now to implement this, you will need an abstract class which will have that particular responsibility and which will also take the next responsibility to be executed. Okay, so let's take the example. Let's go to the code and see the example that we have taken up. What we have done is we have taken the example of a payment processing here. So I'll just give you the gist here that we have the payment processing and we want to process some payments. Okay, that's a simple thing. And we have added the chain of responsibility. What we have done is that we have different types of payment processing. That is the bank processing. Okay, you can process via bank, you can process via credit card, you can process via PayPal as well. This type of different processing you can do. Okay, and what we have added is that if the amount is less than 500, bank can process it. Okay, if the amount is less than 1000, credit card can process those payment, and if the amount is less than 1500, PayPal can process it. Okay, and what we have done is we have passed the responsibility, okay, for a payment processor. For a bank, there is a responsibility that if it's not able to process this amount, it will add the next responsibility to the credit card. Okay, and if credit card is not able to process those payment, it has the next responsibility given to the PayPal. Okay, that way the responsibilities are shared along and the payment will be done for us. Okay, so that's a simple agenda here. Let's go to the code, and here you can see that I have given the basic information here as well, and I have also given from where I have taken this reference. So if you want, you can go through this reference and you can learn more about it. Okay, and you can share some love as well to the creator. So now you can see we have created a simple abstract class here, that is the payment handler. Okay, this is something will be able to handle our payment. And within this payment handler, you can see that I have created one more property, that is the next payment handler. Okay, so you can see that I am having the property of the next handler, that is the next responsibility that it is going to do. Okay, simple thing, that is my handler. And what's going to be my next handler? What is going to be my next responsibility to complete? Okay, so that two things I have added here. And this is the method to add the next responsibility, simple thing. And now you can see this is a method, abstract method, which is going to handle the payment, which will take the amount and which will handle the payment. This is something will be implemented by the concrete classes. Now let's go to the concrete classes, that is the bank payment handler. Okay, so this is a bank payment handler which is extending payment handler. Okay, and this has the handle payment method which is taking the amount. And there you can see it's simple thing. If the amount is less than 500, okay, process it, else go to next.handle payment. Simple. Okay, if I'm able to handle it, that's good. I'm not able to handle it, call the next responsibility. Okay, simple. Same way, if I go to credit card, that's the same thing, that I'm able to handle 1000 rupees, okay, $1000, whatever the currency is. If not, then go to the next handler. Same way for the PayPal as well, that if I'm able to handle this, that's fine. Otherwise, go to the next handler. So you can see that my all the handlers are ready. I have my base handler, that is abstract class, and all the classes implementing this handle payment method. Okay, now this is my main method, that is the chain of responsibility application. This is my main method, and what I'm doing is I have created 3 payment handlers, that is bank payment handler, credit card payment handler, and PayPal bank payment handler. And here you can see that I have added the responsibility, that bank has the responsibility of credit card. It will give the responsibility to credit card. Credit card will give the responsibility to PayPal. And now you can see that with the bank, I am calling all these different methods. Okay, because your bank is your base handler, right? That's the starting point. So from there, it will be able to traverse requests throughout the all the responsibilities that you have given in the chain. So that's the idea about the chain of responsibility. Now we will go through this all the different methods, and we will try to identify that which particular method will be called where. Okay, so this is $600, and $600 we will call bank handle payment method, and bank can only handle 500, so it will be calling the next possible handler available. Okay, so the next possible handler we have added is credit card. Credit card can handle 1000, so it will be processed by credit card. Okay, bank handler was skipped. Same way, you can see this is 200 can be processed by bank itself, so it will call that bank handler and the rest will be skipped. Same way for 1200 can only be processed by PayPal, so bank will be skipped, credit card will be skipped, and PayPal will be executing this. Same way for 600. So let's run this and test our all the things. So you can see that first 600 was same, handled by credit card, 200 was handled by bank, 1200 was handled by PayPal, and 600 was handled by credit card. So you can see that how easy it is to implement this chain of responsibility design pattern. So you need to understand where you can fit in this and how easy it is to implement. So you can just have to have one basic handler and the property of next possible handler you want to call. There are different various modifications also available, but this is the base of it. Okay, once you understand the base of any design pattern, you will be able to modify it alongside what actual your need is. Okay, so this is all about the chain of responsibility design pattern, and it's part of the behavioral design pattern. In this video, we are going to learn about the command design pattern. That's the part of the behavioral design pattern. So let's get started. Now, before understanding the command design pattern and how we can implement it, let's see one scenario here. By definition, command design pattern says that rather than directly executing any request with your business logic, what you will do is you will convert your request into command, and that command will be executed by your business logic. So rather than any request directly executing by your business logic layer, right? Directly any request directly been executed, what you will do is your request will be converted to any command first, right? And this command will be executed by your business logic. So you can see that your entire request will be converted into one object, and that object with all the different methods and everything, it can be executed by your business logic. Okay, so that command will be as the input parameter for your methods to be executed. So directly you won't be executing any request, you will be executing a command, and that command can be executed by multiple ways. So that's one command, right? That command will have all the information like what is the request, what is the input data and everything, and directly with all those information, command can be executed by any of the different receivers or the invokers. Okay, we will understand what are the different receivers and invokers, but that's a gist about the command design pattern. So let's take one example. You are creating one text editor. Okay, in that text editor you will have different kinds of button, and all those different buttons will have the different functionalities. Okay, so let me just take this here as a text editor, and this text editor will have different buttons. So suppose I'm creating different buttons. Okay, suppose consider I'm creating a base button. Okay, that's the base interface that I'm creating. With this button I might have different kinds of button. That is a copy button, okay, paste button, open button, suppose save button, right? So these are the different buttons that I'm creating. Okay, for all this button, my button class, my button interface is a base interface, that's a base object, and all the different functionalities, all the different buttons will have the different business logic. Okay, copy will do copy, paste will do paste, open, save. Similarly, all the buttons will do the different things. Okay, so that's one of the scenario, and what it will happen is you will be creating a different subclasses to have those functionality. Okay, so you'll be doing this way. Now suppose one more situation comes that, okay, you have written the logic of copying, okay, like how to copy like data and everything. So that business logic is written already. Okay, now there is a functionality like when you do a copy, okay, what we can do is we do a control C as well, right? Copy, right? Control C or command C to copy. So that is also one functionality. So when you do this control C, at the same time you have to invoke the same business logic that you have written for the copy. Okay, so you can see that your business logic, your command execution is same for multiple things now, right? Not just button, you also have a shortcut that does the same thing. Okay, that does the same copy, paste, open, whatever it is. Okay, so now you have two different types of command that can do the same thing. Okay, one is button click event and one is shortcut. Okay, so that way, that is a button click and one is a shortcut. Now there might be multiple things can be added as well, right? So for each and everything, if you are doing a request to the business logic layer to do the same thing, like when you click a button, when it's a copy button, do this copy button operation. When the shortcut is command C or control C, do the copy operation. You can see that you will have a lot of duplicacy of the code and a lot of things will happen, and maintaining that code will also be difficult at that time, right? So rather what you can do is, for any type of request that you receive, right? Any type of request that you receive, what you will do is that all the request can be converted into a command. Okay, and this command can be executed by your business layer. Okay, your business layer will get that command and that command will be executed. So whenever I click a copy button, okay, it will take that request, it will take the input data and it will create a copy command. Okay, I will create this command as a base interface. Okay, and multiple interface and multiple concrete classes can be implemented by this command. So I'll create a command. Okay, this command is a copy command. When I click Control C, at that time also I'll create the same copy command, and this copy command will be passed along to the receiver, and that receiver will perform that operation over here. So that's the basic idea about converting any request directly being executed to a command, and that command can be executed. Okay, so there are different components to it. So one of the component is command itself. Okay, so you can see that these are all the commands that we created, right? So any command can be executed. So that's a basic command. You will create an interface for it, and different commands can be implemented. Concrete classes can be created to have that command executed. With that command, there is a receiver as well. Okay, there is one component called receiver. So what receiver is? Receiver is actually a particular component that will be executed. So suppose I want a command that is the open file. Okay, so this is the command, and receiver would be file itself. Like this file will be opened, file will be saved, file will be copied. So all that operation you can see will be the part of receiver. That receiver will get the command. Okay, I'm a text file. Okay, consider this is a text file. This text file will receive a command to open. So that's a receiver, and this receiver will do that operation. Okay, so that's the receiver part. One is the invoker part. Okay, this invoker will be invoking all the different requests. This invoker have the list of different commands to be executed on receiver, and that particular invoker will be executing all the commands one by one. This is very helpful when we want to do redo operations or undo operations. At that time, this type of invoker is really helpful, right? So I will have the list of commands that are already executed on a receiver. Okay, so suppose couple of copies were done, couple of pastes were done, couple of cuts were done, all those lists I will have, and if I want to undo or redo, I can do all those commands, and all those commands will also have the data to it. Okay, so this way invoker will have the list of commands, and those commands can be executed. And one would be client, right? Client will be the one which will be using the invoker to invoke all the functionalities of the command design pattern. So these are the basic components of a command design pattern, and I also explained you the basic, like when we will be using this command design pattern, like whenever we want to have the implementation by multiple places, right? Multiple things are calling the same thing at the time. Rather than duplicating the code, we can create the command out of it, and that command can be executed by any of the receivers. Okay, so when this type of situation arrives, we will use the command design pattern. Okay, so one is like creating a command, and one is like executing that particular command. Okay, so that is the type of relationship we are expecting here. Okay, so let's understand with the code here. Okay, we will be using the same example for the text file. So let me just open my IntelliJ IDEA, and here you can see that I have given you the definition as well and the references that I have used. You can go to these references and you can understand more about the command design pattern, and you can support the creators as well. Now let's first understand about the command. Okay, so here you can see that I have created a command that is the text file operation. Okay, this is the interface I've created, and I've created as a functional interface so that this can be used as a lambda expressions as well if we want to use. Okay, so that's why this is not mandatory, but it should be interface, and this interface can be implemented by the concrete classes. So that's the text file operation. So I want to do any operation on a text file. That's the command I want to do, and this command, you can see it has a method that will be executed. Okay, to execute a particular command. So this is the interface. Now let's implement this interface. So this interface, you can see I have created one more operation, that is open file. That's the open text file operation, which is implementing text file operation. So you can see that this is the concrete class implementing the command, and here you can see that I have the reference of the receiver. Okay, like what is the receiver which will be going to implement or execute this command. Okay, so for my open, what I want to open a text file. So that text file is my receiver. That text file will be executing that particular command. Okay, so that's why I have given receiver here, and this is the constructor to pass the receiver here, and you can see that this is the method, okay, which is returning null. So that means I have just implemented this particular method. You can do any operation over here. Okay, that's fine. Now same thing over here, that is the save text file operation, which is implementing text file operation. That's the same thing. This is the concrete class which is implementing the interface here. This also have the reference of a text file. Okay, this text file is the receiver. We will go to the text file as well, like what it is text file. But here you can see that for this save text file, we have a constructor and the method implemented. Okay, what we are implementing? We are implementing text file.save. Okay, here as well we can do the same thing. We can do text file.open. Okay, now all this method we have placed in the receiver itself. So if we go to the receiver, that is the text file. Okay, here you can see that I have just created simple text file, and this text file have some properties. Okay, suppose it has a name and it has the different methods. This is just a constructor to pass on the name, but it has method, that is the open method and a save method. Okay, so you can see that receiver is something that will actually execute the commands. Okay, so like suppose I want to open a file, that is a command I created, and with that command I will pass on the receiver and I will call the receiver's open method. So here I did the same thing in the open text file command. Okay, I call the execute method, and for the receiver's class I call this receiver's method, that is the open method of a receiver. So that's the same thing over here, that I call this open method of a text file because I want to open the text file. So these two components we gone through, that is the command itself and the receiver itself. So that's the relationship between the command and the receiver. Now let's talk about the invoker. So here you can see that I have created one executor. Okay, you can call it executor or invoker, which will actually invoke the command design pattern. So here you can see that I have just created the class over here, and this class have the list of commands to be executed. Okay, text file operation are the list of commands to be executed, and here execute operation I have defined one method. This method will take on the command and it will add that command to our command list, like what all the commands that we have executed, and it will actually execute the command. So you can see that this is the method execute operation, which will take the command, it will add the command to our list, and it will execute the command. So we will have the entire list as well, like what all the different commands we have executed. This is helpful when we want to do undo and redo operations. Okay, so this is my invoker. You can have any logic in your invoker. This invoker will be used by the client to execute or to call our command design pattern. Okay, so this is just a simple method which will take the command to execute it. Whatever the command we pass, that will be executed. Now let's go to the client. Our client is the command application. Okay, here you can see that this is the executor that we have created object, and within this executor you can see that in the execute operation, okay, we have here, right, execute operation. Let me go back. Execute operation method is there, right? In that it is taking the command itself. So here we are passing within the first executor, means within the first method what we are passing is we are passing open command, that is the open text file command. Within that I am passing a new text file and the name of the file. So this operation will be executed on this file. Okay, so you can see that we are calling receiver command, everything from the executor itself. The second thing is within the same executor command we are passing save text file operations. So that means we are passing the save command to a text file. What is a text file? There is a new text file we created and we pass the file to over here. So you can see that how every component is been used within the command design pattern. So this is how we will be implementing the command design pattern. These are the 4 components that we went through, that is the command, receiver, invoker and the client itself. Okay, so you can see that it's very easy to implement. You will need one interface. That interface will be implemented by the concrete class as the command. There will be one receiver that will perform all the operations for you. Okay, so for us, for open command and a save command, what is the receiver? A file is the receiver, because file will be opened and file will be saved. Similarly, you can identify your commands and receivers for your particular application, and accordingly you can design your system. The next thing was the executor. Executor will be something, or invoker will be something that will invoke your command design pattern and it will execute all the commands for you. Here within this we also store the list as well to list down all the commands, because we want to know what are all the commands were executed, and if you want to redo or undo, we can do that. The next thing was the client itself, which will actually call your executor. In this video, we are going to learn about the Iterator design pattern. So let's get started. Now, Iterator design pattern is a part of a behavioral design pattern which will allow us to traverse through the list of objects. So whenever there is a requirement where we have the collection of objects and we have to traverse through all of those objects, at that time we will be using the Iterator design pattern. So let's understand more in detail about the Iterator design pattern. So generally in Java, whenever we have to store any data, what we do is we try to use any of the data structures, right? So either we might be using arrays, lists, trees, graphs, and there are a lot of other different data structures available. And by using all those different data structures, what we do is after storing all the data, we try to traverse through all those data structures. And traversing through each and every data structure is a different task, because some of the simpler data structures like arrays and lists, for them the traversing is easy, right? Because there is a sequential traversing that needs to be happen, and that we can achieve using the Iterator as well. And for the complex data structures such as tree, in tree we have to go ahead with the different types of iteration. We might be doing the depth first search, we might be doing the breadth first search, or some other random traversal. For that there has to be different implementation of the Iterator, right? What Iterator will do here is Iterator will allow us to traverse through the list of objects that we have, collections of objects that we have. Okay, so Iterator's job is to allow a client to traverse through the entire data structure based on the data that we have stored in the different data structures. Okay, either it may be array, list, tree, whatever it is. Okay, or with the Iterator it should allow us to go through the data structures and fetch the data. Multiple different iterators also should be allowed to traverse through the data. So that's the general idea behind the iterator design pattern. Okay. Now, as we talked about, like different data structures might have different types of iteration that needs to be done. There has to be different implementation of the iterator as well, right? So what generally we'll be doing is there has to be an interface of the iterator. Okay. Generally, it has to be have the interface, and this interface should have the different implementation, right? Different implementations. Now this different implementation will be used in the different types of data structures. Okay, suppose for list there might be different implementation, for array list there might be different, for trees there might be different, and so on. Okay, so for all these different types of data structure the implementation may vary, but all of them would be implementing this iterator interface. Okay, so this iterator interface will be implemented by all of these different interface, so there is no compatibility issue between all these different classes of the collection. Now the best example to see the iterator design pattern is within the collection framework itself, right? So in the collection framework, for all these different classes we can see there is an iterator available, and with the help of that iterator we can traverse through the different objects in the collections. So let's see the same example here. Let me go through the IntelliJ IDEA here. Okay, and here you can see that we have opened the array list. Okay, array list is extending abstract array list, and it is part of the collection. So if you see this collection interface, right, this collection interface is extending iterable, so that means this can be iterated. Okay, and that's why it has the object of the iterator. Okay, so here you can see that this iterator is an interface. Okay, and this iterator will allow us to get the next object of the collection available. So here you can see that it has the method that is hasNext and next, which will check if there is an object available, and if so we should get the particular object as well. So that's the general idea behind the iterator. It should give us the different objects or the next objects available until that particular collection is empty. Okay, till that we should get the objects. So that's generally the iterator should work. Now this is the general interface. You can see this is the interface. Now this interface should have different implementation based on the different classes of the collection, in general for the different concrete classes. Okay, so here within the Java you can see that there are 351 implementation for this iterator. So if I just scroll through, you can see there are a lot of different implementations for the different collection. Here you can see that for list there is one, list adapter, list buffer. Okay, if I scroll down you can see there are a lot of different types of implementation available. Let's take the simple one, array list. So there is an implementation for the array list as well for this iterator. Okay, so here you can see that it is a simple list iterator which is extending iterator. Okay, and it is just, you can see that getting the current index to get the current data. So there might be different implementation. You can see there is a implementation for the list iterator as well, which is extending the iterator. So there are different types of implementation available for the iterator. At the end, the main purpose is to have a particular interface and the implementation concrete classes for that interface, which will allow us to traverse to the different objects based on the collection. It might be list of dogs, it might be list of anything. Okay, it might be custom data structure as well that you have created, but if you want to traverse through anything, iterator design pattern is something that you have to implement. So that's the general idea behind the iterator design pattern, and you have seen and used this iterator design pattern a lot in Java as well. In this video, we are going to learn about the Mediator design pattern. So let's get started. Mediator design pattern is a part of a behavioral design pattern, and as the name suggests, it behaves as the mediator between the different kinds of objects and different types of behaviors. So that's the basic idea. Let's first understand what is mediator. Let's take the real world example. Let's take the example of a ATC and the different planes revolving around and trying to land. Okay, so there are 2 to 3 planes which wants to land on an airport, and what they do is they cannot talk directly between them, right? Because there might be chances of miscommunication as well, and there might be other different challenges as well. So what they do is they talk to ATC. Okay, ATC is a mediator, and that ATC is responsible to get the data from the different airplanes and to provide the data back to the different airplanes based on the different status and notifications. Okay, so that's the general idea. So all the airplanes are connecting to ATC, and ATC is giving the information back to the pilots. What should be done, which plane should go first, and all those information. Okay, so that's the general idea, and where ATC is the mediator. So in our programming as well, this type of situation happens where multiple objects are created and there are a lot of dependencies and everything, and because of that application gets tightly coupled. And when the application gets tightly coupled, the communication between the different objects and how separately we can create those becomes very tedious, right? So at that time what we do is we try to have a mediator, and that mediator is responsible to have the communication around the different objects. Okay, so that's the same idea that we are going to use in the mediator design pattern as well. Okay, so when you have different objects and you have very huge amount of dependencies, and to reduce that dependency, what you do is you add a mediator, and that mediator will be responsible to have the communication between the different objects. They will not be directly communicating to each other. There will be mediator which will be communicating between the two. So they both the objects, all the different objects per se, will be independent of each other. Okay, so the application is loosely coupled. Let's understand with a simple flow here how the mediator design pattern will be implemented, and we will take with one example as well. So for the mediator design pattern, what we will be having is we will be having a mediator, okay, which will be responsible to have the communication between the different objects. So this mediator will be the interface, okay, and this mediator will have multiple implementation of this mediator, okay, multiple implementation. And to call this mediator, there has to be a colleague, right? So there has to be class which will call this mediator, okay, for the different types of objects. So we will call it as a colleague or a component or anything, okay, so whatever you want to tell. And this also is going to be the interface or per se abstract class, okay, and this abstract class will have the object of a mediator, which is this one. So this component has the object or has the reference for mediator. So that means all this different implementation of this component, maybe component A, component B, whatever, okay. So now all this component A and component B, if they want to interact with each other, they will interact using this mediator, okay. There will be a behavior added, there will be an extra implementation added that will allow these objects to communicate between each other using this mediator. Okay, that's the simple idea behind this mediator design pattern. So we have the mediator and we have the different implementation of the mediator. We have the component and that component has a mediator. Okay, so with that particular mediator, what are the different implementations or different categories of the component? They can communicate between each other using that mediator object, which is this one. Okay, so that's the idea. Now we will take one simple example of a chat application where we will use this mediator. Okay, so let me just show you that example. Okay, I hope this is clear, because mediator is just one extra object that will help to communicate between the different objects. Okay, so that's the same idea we are going to use here in our application. So here you can see that we have created the chat mediator, and you can see that I have added the references as well from where I have taken this example. You can visit their website and share some love as well. So this is a simple interface chat mediator. Okay, so that's a mediator that we have created, and what this mediator will do, this mediator will send a message. Okay, so you can see there is a method which will send the message, and there is a method which will add the user to the users. Simple two method. Okay, so it will take the user and add the user, and it will send the message, whatever the message it is, to a particular user. So that's the only two thing this chat mediator is doing. If you go to the user, okay, you can see that this is the user, and this user, this is a component. Okay, what we talked about here, right? This is a component. So now user, you can see that user, this component has an object of mediator. That's why this user has a mediator. Okay, so this user now has a chat mediator which is named as a mediator. And now you can see we have the extra fields as well, and we have the constructor to initialize all the fields. Simple thing. Now we have two abstract methods for this component, that is user, that is send a message and receive a message. Two things. Okay, we are sending a message and we are receiving a message. Now this component has its implementation. Okay, so this user IMPL, we can go here, and this has its implementation. There might be multiple components as well. Okay, now this user IMPL extends user, it has the constructor which is initializing the values here, and it has the implementation of send and receive. Okay, two things. Now send, it will take the message, it will print the message. Okay, you can see it is printing the message, and it is calling the mediator send message method. Okay, where we are passing the message and we are passing the mediator itself. Okay, sorry, not mediator, component itself. Okay, if you go to the chat mediator, you can see that send message is taking the message and it is passing the user, that is the component. Same, it's been done here. Okay, for the receive as well, it will get the message and it will print out the message. Simple two stuffs. Okay, the implementation. Now this was the component and its component implementation. Okay, now we have to have the implementation of the mediator as well, because there might be different mediators we want to call. Okay, we want to invoke. So this chat mediator implementation, you can see this is implementing the chat mediator, which will have the list of users. And this chat mediator was having two methods. One was add user and one was send message, right? So this add user method, you can see it is just adding the user into the list, and send message method, what it is doing is it is taking the message, taking the component that is the user, and for each and every user, it is calling the receive method. Okay, so you can see that we are not directly calling users or everything. We are just using the mediator. That mediator is calling the users method, okay, which is invoking the components method. Okay, so that mediator is between each and everything, and mediator is responsible to sending and receiving part. So this is how you will be implementing the mediator design pattern. If there are different components of the mediator and different implementation of the user as well, that is the component, those will be able to talk to each other using this mediator, because this mediator will be available throughout its implementation. So that is the general idea about the mediator design pattern. You might have used this mediator design pattern in your day-to-day work as well. If you have used it, do let me know in the comment section below how you have used it. And if you have not, go through this video, and if you try to use it, also do let me know in the comment section below that how you tried to use this mediator design pattern and how this fit in your application as well. So that's it about the mediator design pattern. You do not have to mug up each and everything. Just a basic understanding would be good enough to answer your interview questions regarding the design patterns. In this video, we are going to learn about the observer design pattern. So let's get started. Now, observer design pattern is a part of a behavioral design pattern which will allow us to have an object. For that particular object state, there might be different subscribers. That subscriber will be notified based on there is some change in the state of a particular object. Okay, if it's confusing, don't worry, we will understand in detail and with code structure as well. So let's check this out. So suppose there is an object. Let's take the simple example of a news agency and the different channels, right? All the different channels may need the different news available, okay, from the news agency. So suppose there is a news agency and there are different channels as well. Suppose channel 1, channel 2, channel 3, and so on. Okay, so there are different channels available and there is a news agency. Okay, now what is the job of a news agency? There is, if there is any news available, they have to give that news to all the different channels. Okay, and what's the job of the channel? They need to ask for the news agency that if there is any news, let me know. Now every time different channel will go to the news agency, if there is any news, please let me know, I need the news. Okay, so sometimes news agency will not be having any news, right? So they won't be able to give the news. So most of the time what will happen is the call from channel 1 to news agency will be void, right? Because they won't be getting any news. So all those calls will be wastage of resources, right? Same way happened for the channel 2 and channel 3 as well. So what we can do over here is we can have the observer pattern. What it will do is for this news agency, okay, we can have a state. Okay, that means when there is a new news available, okay, when there is a new news available, and alongside that, if there is a new news available, this particular news agency will have the list of all the channels, okay, as a subscriber. So this particular thing will be acted as a publisher and all this will be acted as a subscriber. So this news agency will have the list of all channels, channel 1, channel 2, channel 3, and so on. Okay, so this particular news agency, this object, if I tell you in terms of the programming, this news agency object should have the capability to add the subscribers and to remove the subscribers as well. Okay, so if there is a new subscriber, we can add it, and if you want to remove any subscriber, we can remove that as well. So this news agency, this object has that capability. Okay, so with that we have added all these different subscribers. Now whenever there is a change in state, whenever there is a new news available, what we will do is we will go through all the subscribers, okay, and we will notify all the subscribers about the new news available. So you can see that whenever there is a change in state of an object, at that time we are updating the subscribers about that news. Okay, so we are telling that subscriber, okay, this is the new news available, you can, whatever you want, you can do. Okay, so that's the observer pattern that we define. These are the observers. Okay, these are all the observers, and this is the observable. You can name it as a publisher, subscriber, or observable, or observers. Okay, so this is the simple thing, that there is one observable and there are different observers, and this observable will have all the observers, and for any state change, any change in the object, okay, it will notify all the subscribers about that change, and we will call the subscribers update method. Okay, we will see this in detail with the code demo as well, so you will get the better understanding. Okay, we will take the same example with the news agency and channel. So let me go to the IntelliJ IDEA. So here you can see that I have opened the project, that is the observer, and you can see I have the channel available. Okay, this channel is nothing but your observer. Okay, that is your subscriber. So if you see, this is the channel, this is your subscribers, right? So this is your particular subscriber. So this channel, you can see that I have created the interface. Okay, so this interface can be implemented by the different concrete classes. There might be n number of different types of subscribers available, right? So if all of them are implementing this interface, they don't have to use the different methods, they can use the same method, and we can call all the update methods. Okay, so that's why you can see that I have the interface channel available, and there is one method, that is the update, and this update methods needs to be implemented by the concrete classes. So let's take one example. This is the news channel, this is one of the concrete class. Okay, and here you can see that this news channel is implementing the channel, and it has a object, that is the news. Okay, so what will happen is, you can see that this update method we have implemented here, and it is taking the news object here. Okay, and what it is doing is, it is setting the values to this news attribute. Okay, this is the simple job of that update method. Whatever the data has been passed as a news, we will assign this value to our local variable, that is a news. Okay, and we have the getter setters to get the news and set the news. Simple thing. So this is the job of your subscriber. Now let's take a look at our news agency, that is our observable, that is our publisher. Okay, so if I go to the news agency, here you can see that I have defined the definition as well, and I have also defined the references that I have taken from. You can share some love as well, you can visit their websites. Okay, now this is the news agency, this is the class, and you can see it has a value called news. Okay, so news agency will also have the news, and that news has to be published to the different channels. Okay, that's the point. Now, as I have mentioned you earlier, that news agency will also have the list of subscribers, which all subscribers I need to notify, right? So that's why I have the list of channels available. Okay, now I also told you that this news agency will have the capability of adding a subscriber and removing the subscriber as well from the list. Okay, so for that, these are the two methods: add observer and remove observer. You can see that we are taking the channel and adding to the channels list, and the same way we are taking the channel and we are removing from the list. Okay, so that's the capability. Now we need to notify to all the subscriber based on the state change. Okay, so now when there is a state change, what we will do, we will using the set news method, that is a setter method. So whenever a setter method is been called for this particular observable, okay, what we will do is, we'll get the news, we will set the news here, and after setting the news, what we will do is, we will go through all the channels available, that is all the subscribers available, and we will call the channel.update method. This channel.update method is available here. Okay, this update method, and what this update method will do is, this update method will update the news in the subscriber. Okay, so now subscriber knows that, okay, there was a change and update was called, okay, for the channels method, and now that news can be used by the channels to publish or whatever they want to do. Okay, so you can see that channel doesn't have to go each and every time to the news agency to get the news. News agency, in fact, when there is a change in the subject, when there is a change in the state of that particular news, it will publish all the news to the different channels. So you can see that all the channels are observing if there is a change available, and we are getting those state changes. Okay, so this is how the observable pattern will work, and you can see that it's very simple to implement as well. What you need the observable or a publisher, and the observers or the subscribers. Okay, so based on that, we will have the add observer and remove observer method in our observable to add the different observers and to notify all those observers as well based on the method that we have defined in the interface. In this video, we are going to learn about the FlyWeight design pattern, which is also known as cache design pattern. So when to use the FlyWeight design pattern? Let's first understand that, and let's understand with one example as well within the code, like how we can design the FlyWeight design pattern, how to use it. So there are three scenarios where we can use the FlyWeight design pattern. Whenever your application has a huge number of object creations, so whenever you're creating the objects, those objects are in huge numbers, that's where we can use the FlyWeight design pattern. Also, the objects that we are creating are very huge or very heavy in processing. So it is taking too much time in creating those objects within the memory. If that's the case, we should use the FlyWeight design pattern. And the other thing is, whenever the object's properties can be divided into intrinsic properties and extrinsic properties. Now, what is intrinsic properties? Intrinsic properties justifies that the object is unique. Okay, whenever any properties are set with that property, if the object is unique, we will call it as a intrinsic properties. And what is extrinsic properties? Extrinsic properties are something that will be added by the client itself. So whenever there are properties that needs to be defined by the client, those properties will be extrinsic properties. And if any object is been divided into two parts, that is intrinsic and extrinsic, that's when we can use the FlyWeight design pattern based on how we can create this object. Okay, so if we are creating huge objects, right, that means we are creating a lot of number of objects and the objects are also heavy, right? That's when we will be using the FlyWeight design pattern. So suppose, let's take the example where you have to create a lot of objects, right? So let's take the simple example where you are creating the shapes, right? So suppose you have to create shapes, and whenever you want to create a shape, suppose you have oval shapes, you have line, you have rectangle. Okay, these are the different shapes that you have, and whenever you want the object, what you will do is you will call the constructor of these, okay, to create the objects. And whenever you will call the constructor, the new object will be created for it and you will get that particular object. And suppose for every object creation, suppose it is taking around 1 second. Okay, so it's taking 1 second to create the object. So what will happen is, like, whenever you will call that I want the object of an oval with all these properties, like it should be filled, it should be not filled, it should be with this border, it should not be with this border, it should be dashed, whatever the properties are. And there might be some properties defined by the client as well, like the oval should be drawn at this x and y direction, all those different things are there, and the oval should be with this much width and this much height. All these different properties will be set by the client. Those are extrinsic, like what should be the fill, what should be border, all those are intrinsic properties that can be directly used. If there is a case and the object creation is taking too much time, so for every object creation it will take that much time and the processing will be too slow, right? So it's very huge and heavy process as well. So to avoid this scenario, we will use the FlyWeight design pattern. In FlyWeight design pattern, what we will do is we will have the interface for shape. Okay, let's use this example itself. We will have the interface for the shape, and for this shape different concrete classes are there. Suppose line is there, oval is there, rectangle is there. Okay, now based on this concrete classes, all these concrete classes will have the intrinsic properties and extrinsic properties. Intrinsic properties and extrinsic properties all will have different types of properties. I suppose line will not have any intrinsic properties, it will have extrinsic properties, like to which position the line should be drawn. Oval, like oval should be filled or non-filled, the border should be normal or dash border. These are the different intrinsic properties. Extrinsic properties will be like in which position this oval should be drawn. Those are the extrinsic properties. Okay, so you can see that there is a difference where we can identify the intrinsic and extrinsic properties for each of the different shapes. Now for all of this, there will be a constructor as well, right, to create the object, but directly we won't be using it. Client won't be directly using the constructor to get all the objects. What we will do is we will create a FlyWeight factory. Okay, and from that factory itself the objects will be created, right? So what I'll do is I'll create a FlyWeight factory, and within this FlyWeight factory we will define what type of shape you need, and based on the type of the shape, what we will do is based on the type we pass, okay, based on the type we pass, what we will do is we will have one hash map. What we will do is we will store all the different objects. We won't try to create each and every object every time. If the object is available within the map, we will use the same object. If not, we will create the new object and we will store in the hash map. So every time what we are doing is we are not creating the object. So that means whatever the heavy lifting is there to create the object, that we are minimizing. whenever the object is created with the intrinsic values and we need the same object, we will just return it. Suppose the type of the object is I want oval, filled oval. Okay, that is one of the type. Suppose I want oval as non-filled. Okay, suppose I need a line, suppose I need a rectangle as a filled. Okay, these are the different types of object. Now what will happen is, based on the type defined here, okay, within the map we will check if this particular type is available or not. If not, we will create a new oval with the type whatever is defined, that is filled, with the intrinsic values, and we'll create the object and we will store the same object in hash map as well. And the next time if the client is asking for the same oval field, we will check in the hash map and we will return the same object. So whatever the time is getting consumed in creating the objects, that has been neglected now, and all the intrinsic values are already set within the object and those objects are already available. So directly we can utilize those. Okay, so that's the general idea behind the FlyWeight design pattern and the FlyWeight factory, which will help us to utilize the already existing object with the intrinsic values, and the extrinsic values will be directly been set by the client, which is calling this factory. Okay, so this was the overall idea about the FlyWeight. Let's see with the example as well. So let's see the same example that we have used here, that is the shape one. So if I go to the code here, okay, you can see that I have created the FlyWeight project, and within that we have different classes. So let's first go here. I have the shape interface here. You can see that this is a shape interface, and within this interface we have one method, that is draw. And what draw is doing is, it's taking the graphics, it is taking x and y position, width and height, and the color of the shape that you want to draw. This is a simple method defined, and all the different shapes that we are going to create, that will implement this draw method, and all the different shape will have the different intrinsic and extrinsic values. So let's go towards the line. Okay, so line is implementing shape, but line doesn't have any intrinsic values. So what it is doing, it is just having a constructor here, and what we are doing is we are just printing that creating a line, and I am just adding a thread.sleep of 2 seconds. Why I am adding is just to have the delay, like just to mimic that the object creation for line is taking some time to create. So whenever I'm creating the object first time, that time there will be a delay, but next time when I want to use the same thing, there won't be delay. To mimic that, I am just using the thread.sleep here. Okay, so this is the constructor that I'm using, and there is a draw method as well, where I'm taking the graphics line, all the XY positions and everything, and I'm just setting the color and I'm drawing the line here. Simple thing. Okay, if I go to the oval here, you can see that for oval also I'm implementing the shape, and for oval there is an intrinsic property, that is fill. What is the fill type? Do I want to fill or do I not want to fill the oval? For same thing, there is a constructor here, and this constructor, you can see that I'm taking the boolean f here, that is fill true or not, and I'm taking the thread.sleep here to create the object. Similarly, I'm just using the draw method to draw that oval. Okay, now for this you can see that we have the shapes here already. Now as you can see that we have discussed about the FlyWeight factory, here also we have used the FlyWeight factory, that is the shape factory, and this shape factory will identify the different objects based on the intrinsic values, and it will return the object if it's available. So here within the shape factory, you can see that we have the hash map of type, shape type, and shape. Okay, shape is the interface that we have defined, that what type of shape it is, and shape type we have defined as the enum here. You can see that what type of shape type it is. It's oval fill, oval no fill, line, whatever you want to create accordingly. Okay, and now with the get shape method, you have to pass the shape type, and based on that the object will be created, and that object will be available within the hash map. Suppose here, let's take the example of oval fill. We will get the oval fill here as a shape type, and we will here check within the shape implementation that shapes.get. So within this hash map we will do shapes.get oval fill. Oval fill will not be available because the object is only just created, so we will get null here. And if we are getting null here, what we will do is we'll check what is the shape type. If it's oval fill, what we will do is we will create a new oval with true. If it's no fill, we will create new oval with false. If line, we'll just create line. And whatever the object is created, we will put that object within the map and we will return the object. So you can see that only once that object is created with the intrinsic values, and that object will be available always within the hash map. And from that hash map, we will return the object when it's been called second time. Okay, so that's how the entire design pattern will work. And let's see the client as well. So how client will call this. Okay, so this is the entire code here. I have just used this code from the DigitalOcean. I have added the link as well. So if you want to read about it, you can go through it. That's the same example that I've used here. Okay, it was a really good example, so I took this. Now here, every time you can see that based on the shape type we have defined here, right? Shapes, and based on the shape type, different random shapes are created. So if I run this example, you will see that for the first time when the objects are getting created, it will take time. But after that, the same objects are being reused. For that, it will not take that much time. So let me just run this application. So you can see that this is the application here. Okay. Now what I will do is I will just click on draw. After clicking on draw, it will try to create the objects. First time it will take some time to create the object, but next time those objects are already available. So it will just save time and it will reutilize all those objects that are already been available. So I'm just clicking draw. It's taking time, and now you can see that first oval is created, then second, and you can see that a lot of objects are created. So you can see that for the first time, first filled and first non-filled oval and first line took time, but after that it was very quick, right? So this is how the FlyWeight design pattern will work, which means it is caching everything, right? So that's why it's also called as cache design pattern. So this is how the FlyWeight design pattern will work. If you have any doubts regarding any of the things that we have covered, then do let me know in the comment section below. In this video, we are going to learn about the interpreter design pattern. Now, interpreter design pattern is a part of a behavioral design pattern, and it will allow us to interpret things as the name suggests. So suppose, let's take the example of any language or any expression. What we have to do is, for any language, we have to interpret things, right? Like what that particular expression says. Suppose there is an expression which says that Priya is female. Okay, this is the expression. Now how we will, or how a language or how an interpreter will able to understand that what this particular expression means. So there has to be an expression which identifies all the different keywords there, and based on the keywords it will identify what this means. Okay, suppose I have the expression defined. Okay, I have the expression defined which takes something as an input. Okay, suppose it's taking the string as an input, so it will check that, okay, for any expression that I got, okay, and if that particular expression contains Priya and it also contains female, okay, that means that Priya is female. Okay, now this is the expression. Now if I am passing this thing Priya here, Priya is a female here, within this expression it will check, okay, this particular expression has Priya as well, this particular expression has female as well. So it's checking both the things. This is also true and this is also true, right? So both the things are true. That means the entire expression is true, which suggests that, okay, Priya is a female. So I can say it's an AND expression. I can define this as an AND expression. I can define one more as an OR expression as well. I can define a normal expression as well, just to identify that particular sentence is true or not. So there are different ways that I can define the expression for the interpreter. So interpreter is nothing but an expression evaluation where different types of expression is passed, and based on the logic, that expression has been evaluated for a interpreter. Okay, so interpreter is nothing but an evaluation of the expression, and it will just return what actually that value is. It's a positive value or negative value. So ideally, if you are working for any language or interpreter, that's how it has been done. Okay, so that's the behavior of it, and let's understand with the code as well, like how that particular behavior has been defined. So if I go to the code here, okay, you can see that this is the particular example of the interpreter. I have taken this example from the tutorials point. I have added the link for that as well. You can go through it and you can read about it more there as well. Now currently you can see that what I have done is I have defined one interface, that is the expression interface. Okay, and within this expression interface I have defined one method, that is the interpret method. So whatever the context that I give here, that context needs to be interpreted by this method, and this method will return either true or false. That's a Boolean method. Okay, that's the simple job of the expression here. Now this expression can be implemented by the different types of expression. Okay, suppose let's take one example, that's the terminal expression. Okay, that's the basic expression here, that is implementing expression, and what it does have is it has the data as well. Okay, and here you can see that I've created the constructor here which is taking the data and it is setting here. Now I have implemented the interpret method which is part of the expression here, interpret, and which is taking the context. And what I'm doing is, if that context contains the data, then that means that's a true, otherwise it's a false. So that means if I'm adding the terminal expression as Priya, and I'm adding Priya is a female. That means it was able to find the Priya within that particular context, so it will return true that okay, whatever the data that you have as an expression, that is part of the context as well. Okay, so that will return true, else return false. So that's one of the terminal expression. Let's see one AND expression as well. So within this AND expression, you can see that it is implementing expression, and it has two properties, that is expression 1 and expression 2. And this is the constructor here that I have defined, which is taking expression 1 and expression 2, and it is setting the values here. And I have added the interpret method here as well. Now what interpret method is doing is, it is checking that expression 1.interpret, I'm just interpreting this expression because this expression is also been interpreted. It's a interface, right? So if that is returning true and the second one is also returning true, that means both are returning true, that's true. Otherwise it's a false. So that's an AND expression for me. Similarly, OR expression would be either this or this. Okay, so I've just defined this expressions here. Now when I'm going to call this, you can see this is the interpret application that I've defined here, and here I have defined different expressions. So here you can see that I have defined get male expression. Okay, and here I have defined that Robert and John are male, and here there are two expressions, that terminal expression contains Robert and terminal expression contains John, and if we are passing these two values, Robert or John, within the OR expression, it will return true. Okay, similarly I have one more, that is get married woman expression. So Julie and married, these are the two different contexts that I have provided, data I have provided in the terminal, and we have called the AND expression. If we are getting both the values Julie and married, then this will return true. Okay, and here this is our main method where we are actually calling it. So here expression is male equals to get male expression, and expression is married woman equals to get married woman expression. Okay, and I'm just trying to print this John is male, and I'm just trying to call is male, this is the expression dot interpret. What is trying to interpret? John. Now we are passing John as the context. This context will be interpreted by this expression. Okay, and within this expression there are two values, Robert and John, and this is the OR expression. So whenever there is OR expression, this expression has been called, it will check, okay, we have data as John, this is the context that we have provided, and within that context we have two data, Robert and John, and we are calling OR expression here. So this OR expression will be true and it will return true here. Okay, that's a way similar for the Julie is a married woman. So if we run this, you can see that we are getting the same thing, that John is male, yes, Julie is a married woman, yes. Okay, so this is how that expressions are working, and this is how you will be implementing the interpreter design pattern. You can see that it's very simple. You are just defining the interface, and for that interface you are just defining the different concrete classes, and for all those concrete classes you can define different methods for defining those different expressions. Okay, so for every expression you have to define like what this particular expression means. That's how you define in the language as well. Like you define a tree, like if this are there, this is what it means. Okay, so this is how similar in the interpreter as well. So you have to interpret each and every thing that you pass. In this video, we are going to see about the Memento design pattern. So Memento design pattern is a part of a behavioral design pattern, and it is used when you have to store the state of your objects, and you have to have the capability to restore those objects as well to the previous state. So taking the example that you have the different objects available and you are storing the states of that particular objects. So suppose you are storing state 1, state 2, state 3. These are the different states that you are doing on your object. So there are different modifications on your objects, and for your application to have the capability to restore to this particular previous state. Suppose you want to restore to state 1, you want to restore to state 2, and so on. Okay, if you want to have those capabilities, at that time we will implement the Memento design pattern. Now when you will need this, what is the real-time example? So real-time example is like, take the example of a text editor. You have the text editor, and for that particular text editor you have the object, right? All the things happening within your text editor will be stored here. Okay, so suppose you are storing what is the text here, like what is the data that you have been stored, and what are the number of lines, and all those information. You will store the line number, at which particular line you are at, or you will also add the scroll positions like what you have scrolled within the page. If you have written a lot of data, then there will be a scroll as well, right? So all those information you will store. And whenever you are doing any mistake, what you have to do is you have to restore to the previous positions as well. Okay, so if you want to restore what was there earlier, you have to restore to the previous position as well. Now what will happen with this is there are two types of scenarios, like either for all the things that you have defined here within the text editor, either you give the access of each and every fields, okay, access to each and every fields to identify what is the change and what needs to be changed, or you give all those capabilities to a different class, and that particular class will identify what are the changes and it will help us to restore to the previous state. Okay, so these are the different ways. Giving all the access, all the fields, making as a public, it's not a good idea, right? So that's why we are using the Memento design pattern. Now what generally we will identify within the Memento design pattern is for any state that you want to store. There are three different classes that we are going to create here to implement the Memento design pattern. One would be the Memento. Okay, Memento means the state itself. Okay, like what particular state it is. I want to store a state of that particular object. That is my Memento. I will store there. Okay, one will be the originator, like who is creating that particular state. Okay, who is creating that particular state, and this particular part will be responsible to store that state in my Memento as well, like what was the state of that particular object. Okay, and one would be the caretaker. This caretaker will be responsible to restore my state. Okay, so whatever the states are there for within the Memento, if anything I want to restore, caretaker will be responsible for me to restore to that particular previous state. Okay, whatever I want to do. So this is what we are going to create, what is Memento, originator and caretaker, and these are the different classes that we are going to create, and there will be a client class which is going to call originator and caretaker. And Memento will not be directly used because that will be your state machine, right? All the states will be defined there itself. Okay, so let's take the example. We'll go to the IntelliJ IDEA and let's see that example. Okay, so here you can see that I have opened the Memento design pattern here, and I have taken the references from the tutorials point and refactoring guru. I've added the resources as well, so if you want to check them out, you can check them out as well. Okay, I will add all the links in the description below for you to check out. I will add the link for this code as well, and this is the entire code I have taken from the tutorials point. So here you can see that I am creating a Memento here. Okay, this is the first thing that I'm creating, and within the Memento you can see that I am storing the state. What is the state? And for this state you can see that I have the Memento constructor which is taking the state and assigning the state here, and I have the method to get my state. Okay, that's a simple thing. There is no setter. Everything I'll set within the constructor, and I have a method to get my state back as well. Okay, now let's see about the originator. Originator is responsible to save my states. Okay, so this is the class originator, and this originator have the reference of the state, what state I want to store. So you can see that for this state I have the set state method and get state method as well. Okay, two methods I have. And I have a method save state to Memento as well. So whenever there is a state change, okay, you can see that what I will do is I will save state to Memento. I will call this, and what it will do is it will return a Memento and it will pass the state here. Okay, that's a simple method that it will save state to Memento, will return a Memento, and it will return the object. And there is a method get state from Memento. So whatever the Memento that you will pass here, it will return the state from that. Okay, and it will store the state here within this originator. And we have the caretaker method. You can see that caretaker will have all the Memento here, and it's responsible for you to get that particular Memento to restore it. Okay, so this caretaker has a list of Memento here. Okay, and it has a method add Memento and get Memento. Okay, so you will just pass the Memento here, and that Memento will be added in that particular list. And if you will pass the index, like which particular state you want, that particular state will be returned from here. Okay, these are the three simple classes that we have created. Okay, and let's see how we can use it. Okay, so this is our client application, how client will be able to call it. Okay, so you can see that we will be just calling originator and caretaker. We won't be directly using Memento class. Okay, so we just define originator and caretaker, and with the originator.set state we define one state. Okay, state 1. With originator.set state we define state 2. Okay, And within this state, set state, what it is doing is it is setting the state. Okay, and here you can see that with the caretaker I am adding that state to my Memento. Okay, originator dot save state to Memento, and I'm adding the same thing within the caretaker. Okay, so you can see that originator dot set state, I'm setting state 3 here and state 4 here, and whenever I want to get that state back, what I'm doing is I'm getting caretaker dot get 0, that will return the state, and originator will call that get state from Memento, and we will get a particular state. So caretaker will just return a Memento, and with that Memento originator will get a particular state. Okay, so this is how we are going to call it with originator and with caretaker. We won't be directly using Memento. So if I run this, you can see that the current state would be state 4, and if you want to get the first state, that will be state 2, second state would be state 3, because we have not set the first state here. You can see, right, we have just set the second state. Okay, so this was the latest state, and then we saved it, then it was this one state, then it was this one state. Okay, so this is how the Memento design pattern will work. That's the 3 classes that we are going to create. That is the Memento, originator and caretaker. In this video, we are going to learn about the state design pattern. So state design pattern is a part of a behavioral design pattern which will allow us to do some behaviors based on the state. It is basically how we define the state machines. So let me give you more example what does state machine means and when we will be using this state design pattern. So this type of state management we would be doing a lot in our applications as well, where we will be doing different kinds of behavior based on the different state of the object itself. Okay, so suppose if I take the example that based on the state 1, okay, state 1 you should be doing some different behavior, that is behavior 1. For state 2 you should be doing different behavior, okay, and so on. Okay, this type of things we generally do in our application, and this type of things when we have finite states, what we do is generally we end up using the if else conditions, and based on those if else condition we do all those behaviors, like if state 1 do this behavior, if it's state 2 do this behavior, and so on. But if you have many states within your application, though it has to be finite states, doing this kind of if else conditions is not good, right? And whenever you want to change some behaviors based on the different states as well, it is a better practice to use some design pattern and accordingly change the behavior of your application based on the state it has been passed. Okay, so that's the idea where we'll be using the state design pattern, and this has been used everywhere. So what we do is, let's take one more example of a document. Okay, so suppose I'm creating a document, and when the document state is new, right, that means it will have a different behavior. So whenever the document is new, it has to be written, right? This document has to be written, it has to be saved. Okay, and then once this behavior is done, it moves to the next state of your object. So once this is done, it will move to the next state. That's to be in the draft state, like this particular document has been drafted. Now once this document has been drafted, it has a different sets of behavior. Okay, now once it is drafted, you do not have to write it again or anything. It may be also that we have to revisit, but let's consider that once it is drafted, it is going to a review state. Okay, it has to be reviewed, all those things, and then once it is done, it can go to the complete state, and once it is complete, it can be shared along and something. So there are different behaviors along with the different states. Generally what we will do is, how we will implement this design pattern is, we will have a state. Okay, we will have a state as an interface. Okay, and this state will have any action to do, any action to perform. Okay, based on any state we have, we will do some action, that is a behavior we will do for that state. Okay, that's one interface. Now this interface can be implemented by multiple states, state 1, state 2, state 3, and so on, and for each and every states there will be a different action to be performed. Okay, so now you can see that you have different states defined, and for all those states you have actions also defined. Now with all these states you will also have a context. Okay, now this context will be passed along with every state to identify what is the actual state of the object or what we have to do. Okay, so this context will store the state of the application or the object, whatever we want to do, and based on its context it will determine what state it is and what action needs to be performed. Okay, always. So state will identify what is the state and what actions needs to be done based on the context that we provide. Okay, we will be going through the code as well, so we'll get more understanding, but this is the overall idea where we will define a state interface, and for that state interface we will have the different concrete classes, and we have a context class as well which will store the state of the object or the application. Okay, so enough jibber jabber, let's go to the code and let's understand this example. I've taken this example from Tutorials Point and Refactoring Guru. I have given the references as well. You can go through this links and you can learn more about this design pattern. Okay, now let's start with the state here. Okay, here you can see simply I have defined a state interface, and this state interface has one method, that is do action, and this action will be performed based on the context. This context will store the state. Okay, this is what we defined here as well. Okay, now with this state, as we define that, this state will have multiple concrete classes as well. So let's go to the concrete class. This is a state, and this start state is implementing state interface, and this is a do action. This do action is taking the context here, and you can see that it is setting the context here. Okay, and it is doing some action, two things, and we have a string method to return the state as well. Similar thing, we have the stop state as well, which is doing the same thing. It has the context, it is doing some behavior, and it is setting the state. Okay, and we have a context as well. So you can see that as we defined, context will store the state. So here it has a state here, and whenever the context is created, the state will be null, and we have a set state and get set method as well to get and set the states. Now how we will run the application. So if you come here, you can see that we created a context. Okay, and we call the state as well here. Okay, this is a state created, and we call the do action method on that particular state, and we pass on the context. So whenever the actions will perform, after that the state of the context will be set as start state, and after that we check the state of the application, and then we call the another state. So we change the state and we perform the action, so that action will be performed and the state will be changed. Okay, so if you run this application, we can see that this is our result where player 1 is in start state. Okay, so if you come here, this particular start state will be called, and within this do action you can see that player is in start state. Okay, once this is done, we will print the state, so the state is start state. Okay, after that we call this do action for the stop state, so player is in stop state, and after that we call the state as well. So you can see that whenever we are calling this do action, we are performing the action and we are changing the state based on the context provided. So you can see that we are not doing any if else conditions now. Based on the state, we have the actions defined within the do action method. So you just pass the context what state it is, and it will perform the actions. You will use this when you have finite set of status, and for that status you have different behaviors to be performed. In this video, we are going to learn about the template design pattern. So template design pattern is a part of a behavioral design pattern where we can define a set of instructions that needs to be followed, and there may be a sets of instructions that a client can modify as well. So we can define a template like, okay, these are all the things that you have to do, and you have some liberty as well to modify some of the steps, but it should follow this template. Okay, so this is how a template design pattern will work. Let's take one example and understand more. So suppose I'm trying to create one application where I want to mine the data from different documents. Okay, so suppose I have different documents like PDF, doc, Excel, and some text. So these are some different types of documents that I have. So for all this type of document, what I have to do is I want to extract the data. I want to extract the data and I want to do the mining on it. Okay, I want to get some knowledge, I want to get some information based on the data stored in different types of files. Now what I can do is I can create the application and I can define, I want to define the where the mining source is. I want to open the file, I want to extract data from it. Okay, I want to process the data. Okay, I want to mine the data, whatever it is, I want to close the document. Okay, so this is for PDF. The same thing can happen for document as well, where I want to add the mining source, I want to open the doc, I want to extract the data, I want to process it, I want to mine it and close it. And the same thing can happen for Excel as well, and the same thing can happen for text as well. So here you can see that I am mostly doing the same thing over here, but there might be different processing defined for the different types of document that I have, right? For PDF there would be different, for doc there would be different, for Excel there would be different, and for text also there would be different. Okay, so what I can do here is, rather than doing all those operations differently based on the different file type, I can define a template like what I want to do, and I can give some liberty to the concrete classes, to the client classes as well. Like based on the different types of document, you can modify those operations, but overall they should be done. Okay, so what I can do is I can define a template here. Okay, I can define a template where I will provide, okay, what you have to do is you have to define the first source of the mining, then you have to open the document, then you have to extract the data, then you have to process the data, then you have to mine the data, and then you have to close the document. Okay, this is all I want to do. But now from this, all these things, okay, what I can do is I can give the abstraction to the client as well. So to define the mining source, I can define the abstraction. Okay, like whoever is client can define what should be the source to mine the data. They can define how to open the document, because opening the PDF, Excel, and all the different types of document is different. So they can define how to open the data. They can also define how to extract the data, because extracting the data is also something different based on the different documents, right? But processing of those data, it should be common, right? So it is defined in the template itself. Okay, like once the data has been extracted, default implementation is provided for the process in the template itself. Okay, so this processing will be common. The mining of the data is also common, because how we should mine the data based on the processing that we have defined, that is also common once the data has been there. Now closing a particular file will be again given to the client based on the document that has been provided. So here you can see that we have defined one set of template, okay, for the clients to do something. So we have defined, okay, this is the process that you have to follow, and out of that, these are the abstract methods that you can define yourself, but these are the different default methods that will be implemented directly. Okay, so this is a general idea how template design pattern will work. Let's take one more example of gaming as well. Okay, so here what I have defined is I want to create some classes for the gaming, and what I want to do is I want to define a template how that game should be played, and based on the different types of game that can be changed, right? Suppose every game should be initialized, right? Every game should be started, every game should be played, and every game should be closed as well, or whatever. The end should be, right? Rather than close, let me write end. Every game should be ended as well. So this is a template that I would define, like every game should be played this way. But how that game should be played is some completely different, right? So suppose if I take the example of cricket, right? How cricket will work. The initialization of the cricket, how the game will start will be different for cricket. How it is played, it will be different, and how it is ended is different than football, right? Football will be completely different than cricket. How it is initialized, how it is played, and how it is ended. Those are different. So here you can see that for gaming, I defined the template, but how that template should work, how the different classes should adapt to it is completely different here, right? So this type of scenarios is where you can use the template design pattern. It's really easy to implement. Let's go to the code and understand that as well. We'll take the same example of gaming where cricket and football has been used. So let me just go to the IntelliJ IDEA and show you the code as well. We have taken this code from the refactoring guru and tutorials point, so you can go visit this URL as well to understand more on this design pattern. So simple, what I have defined here is I have defined one abstract class that is a game. Like this is a game and how that game should be played. So we have defined a template here. So the template we have defined is like we have one abstract method initialize, abstract method start play, and abstract method end play. So these are the methods that needs to be implemented by the different concrete classes. Once these abstract classes are defined, we have a template ready. That is a final play method. So once this play method has been called, we have sets of method like first initialize should be there, then start play should be there, and then end play should be there. Okay, so these are the methods that is been governed by the client, and this is the method that has been directly invoked by the abstract class itself. Okay, so you can see we have given the sets of different methods, abstract methods and concrete methods to the client. Now we have two examples, one is cricket and one is football. Okay, so let's go to the cricket. If you go to the cricket, you can see that it is extending the game class, that is the abstract class, and we have overridden 3 abstract methods. So that is we have implemented 3 abstract methods here, that is end play, initialize and start play. So within all these 3 methods we have defined what it will do. It will start the game, it will initialize the game, and it will end the game. Similarly, we have defined for the football as well, where football is been end play method is there. So football game is finished, initialize and start play. So you can see that client has the capability to implement these methods, but when we are going to call this, if you go to this method, what we did here in the main method, we initialize the object with cricket and we just call the play method. Okay, so what it will do is it will entirely play this cricket game where it will call all the methods. Similarly, we did for football as well. We just created the object of football and we just call the play method. It will call all the methods of football where we have defined everything in a template itself. Okay, here. So this is the way that we are going to implement the template design pattern. So you can see it's really simple to implement as well. So this was all about the template design pattern for behavioral design patterns. In this video, we are going to learn about the strategy design pattern. So strategy design pattern is a part of a behavioral design pattern which will allow us to define different sets of algorithm for the different subclasses and how we can use them interchangeably. Okay, I know the definition was confusing, but let's try to understand with one of the examples here. So let me take the example where I'm trying to define one navigation app for the users. Okay, so suppose I'm trying to create a navigation app, okay, and this navigation app will help the users to define their routes, like where to go from where. Okay, this is a simple thing that I'm trying to design for the customers. Once this application was developed and everything was running smoothly, there was a feedback and requirement to have those automated routes as well. So it's like a Google Maps, right? Like where I can define, okay, I want to go here, and it should give me the proper routes based on the different vehicle types that I can use. Okay, so what I decided was, okay, let's try to first build with the car vehicle. Okay, so if it's a car, what I will do is for a car, I will try to identify a proper route for a source and destination, and what I will give is I'll give a proper map. Like if you are going to travel with a car, then this is the path that you should follow to reach to your destination. Okay, so this is the path that route that I'm providing based on the source and destination using the car. Okay, so that is the algorithm that I have defined for car, because car needs a bigger space, so I have to select all the highways and big streets only. Okay, now I got a request and I am enhancing my application to design for the bike as well. Okay, now for the bikes, if I select the bike and if I want to go to the same source and destination, then there might be a possibility that a route is different, because bike can use less space and I should use that particular route so that a user can reach the destination very quickly. Okay, so for that I am selecting a different route based on the source and destination for the bike. So for this, the algorithm would be different, right? For the first, the algorithm was different. So now you can see that for the same route, for the same source and destination, for the same route with the different types of vehicle, I'm using different algorithms, and based on that different algorithms, different route will be identified. Okay, that will have the best ETA. Now the another enhancement that I am providing is to use the public transports as well. Okay, now for the public transport, to define the routes, there has to be different algorithm where I can define you have to take this particular metro or this particular train or this particular bus to reach to your destination, which stations you should go or which bus stop you should go to reach that particular destination. So you can see for that route, the entire algorithm will be different. So you can see that based on the type of vehicles that you define, okay, how you want to travel, your algorithms are also different, right? That means your strategies are different to identify your routes. Okay, so to handle that, we will be using a strategy design pattern where we won't be just relying on the hard-coded if and else conditions. We will just define a separate behavior, separate strategies, and based on the strategy that you define, your algorithms will be selected and you will get a proper result. Okay, so this is how you will be designing the strategy design pattern. let's take one more example and we will go through the code as well. So here let me take the example of a simple calculator where you are doing the addition, subtraction, multiplications and everything, where what you will do is ideally you have to define a strategy first. Okay, so what you will do, you will define a strategy that will be the interface. Okay, so this is what you will define, like you will define a strategy interface, and for that particular strategy there will be different strategies that will be implementing this interface. Okay, so with this what we will be defining is for every strategy there will be a method to perform that action, and all those different concrete classes who is implementing this particular strategy interface will have to implement those do action method. Okay, that's a simple thing. So suppose I'm defining a add strategy as an interface, and within that I am adding the, suppose I'm making a calculator, right? So suppose I'm adding a add strategy to define the addition. Okay, so for that I will implement this interface strategy, and within that action I will perform the addition operation. Okay, if I'm defining the subtraction strategy, don't mind my spellings are really bad and my handwriting is also okay. So for that, this subtract strategy, what I'll do, I'll just again implement the strategy interface and I will do the subtraction operation within that do action method. Okay, and all these strategies will be defined based on the context that we provide. Okay, so this context will have what strategies needs to be used, and based on that we will call the actions method. Now this context is something that we have used earlier as well within the state design pattern, but how we are going to use this context is different than state design pattern. In state design pattern, context used to hold the state itself of the objects, but here within the context it will not hold the state, but it will pass along the strategy, and whatever the strategy has been defined in the context, that strategy will be executed. Okay, so enough jibber jabber, let's go to the code and understand this example. So here you can see that this is my IntelliJ idea and I have defined some classes over here. So let's first understand the strategy interface. So here you can see that I have defined the strategy interface here, and this strategy interface has one method, that is do operation, and this method is taking two arguments, that is number 1 and number 2, and two things should be, and any operation should be performed on these two numbers. Okay, that's the strategy. Now there are different concrete classes for this strategy as well. So the first one is operation add. Okay, so this is one of the strategy. So this operation add is implementing strategy, and it is also implementing the do operation method here. So within this do operation method, it is taking two number and it is returning number 1 plus number 2. Okay, the same way we have used for the subtract as well, where it will return number 1 minus number 2. And the same thing we have done for the multiply as well, where we will return num1 into num2. So we can see that all the three classes are implementing the strategy interface, and all the do operation method is taking two numbers and doing different operations based on the strategy that we have defined. Okay, now we have the context as well. So here you can see that this context will pass along the strategies that needs to be used. Okay, so here you can see that whenever the context class is created, we are passing along the strategy. Okay, but in the state design pattern, what we were doing is whenever the context was created, we were not passing along the state, but we used to set the state based on the context and the methods, that behaviors that we have to call. Okay, so this is a different, where in the strategy design pattern, context will pass along the strategies that needs to be used, and within the state design pattern, context will store the state itself. Okay, so now you can see that the context will pass along the strategy, and that strategy has been used, and we have a method execute strategy where we are going to pass the numbers and we are going to call the operation on it. Okay, so that's a simple thing that we have defined here. Now how client will call this context and strategies. So if we go to this strategy application, here you can see that this is our main method, and what we have done is we have created a context, okay, with a strategy. So what is the strategy? Operation add. Okay, so that means this context should do the addition. Okay, the next one is, this is a new context with operation subtract. So that means this context should do the subtraction, and this context should do the multiplication. So three contexts we have defined, and we have just called the execute strategy for that particular context. So what it will do is, we know that this context is passing the operation add, and whenever we will call this, it will do the addition, this will do the subtraction, and this will do the multiplication. So if you run this application, we should get the same result. So here you can see that we are getting the same result, that is addition, subtraction and multiplication. So you can see that how simply we have defined the strategy design pattern rather than using if else condition. We just define the strategy interface and the concrete classes and a context that will pass along the strategy. So this is how we can implement the strategy design pattern. And if you are using different types of algorithms and based on the some selection attributes, you have to change those algorithms. At that time we can use this strategy design pattern in our applications. If you have any queries regarding any of the things that we have covered, then do let me know in the comment section below. So it takes a lot of time to create this video, so a sub would be much appreciated. It is really free for you and it gives a lot of motivation for me to create such videos. I will see you in the next video. Till then, happy coding. Bye bye.